Now, if Earth were the size of a nickel, Neptune would be about as big as a baseball. That's impressive, but it's nothing compared to the giant ninth planet that might be hiding out there. Now, our Planet 9's discovery saga might have finally come to an end. Turns out, the problem wasn't where we were looking, but how. And researchers might have just made the biggest solar system discovery in decades. You see, the idea of finding a planet beyond Neptune has been around for years now. I know, back in school, you probably learned that the ninth planet was Pluto. But forget about Pluto. It's been demoted to a less fancy category since 2006. What I'm talking about is the Planet 9, a hypothetical giant planet that could be our cosmic neighbor. We've never actually seen it, but scientists are pretty sure it's out there somewhere, hiding in the outer solar system. To explain why they think that, we need a sheet of paper. Hey, here's one. We place a coin on it, and suddenly, it starts to move. Unless we're talking about some kind of superpower, there's no way this coin is moving on its own, right? So, you figure someone must be on the other side, holding a magnet and moving it around. You can't see the magnet, but it explains why the coin is moving. That's kind of what's happening with Planet 9. We can't see it, we can't prove it, yet, but its existence could explain the strange movements we see out there in space. For example, the planets in our solar system orbit on a flat plane that's tilted about 6 degrees relative to the Sun. But why 6 degrees? Well, no one really knows for sure. Some scientists think those orbits might be slightly tilted because of the pull of a ninth planet. Its existence could also explain the unusual paths of smaller objects in the distant Kuiper Belt, a region full of icy debris that stretches far beyond Neptune's orbit. Back in 2016, researchers from Caltech published a study about Planet 9. They suggested it could have a mass about 10 times that of Earth and follow a highly elongated path. That's a scientific way of saying it takes forever to make one trip around the Sun. Because of that, it would be located in the outer solar system, far, far away. It would orbit the Sun about 20 to 30 times farther out than our most distant planet, Neptune. According to scientists, Planet 9 would take up to 20,000 Earth years to complete just one full orbit around the Sun. Since it's crazy far out there, it's almost impossible to see it. So, as cool as this hypothesis sounds, we've never found solid evidence that Planet 9 actually exists. But we might be pretty close. In May 2025, a team at National Tsinghua University might have made one of the most exciting solar system discoveries ever. Alright, so there's a hypothesis that Planet 9 hasn't been discovered yet because we haven't been using the right method. This new study raises an interesting question. What if Planet 9 actually looks brighter in infrared light than it does in visible light? Let me explain. Scientists have been trying to spot Planet 9 by its reflected light. But here's the problem. To spot it in visible wavelengths, sunlight would have to travel all the way out to Planet 9, bounce off its surface, and then travel all the way back to Earth. If a Neptune-sized planet were about 10 times farther away than Neptune, it would look about 10,000 times fainter. But a planet's own thermal radiation, its heat, only has to make a one-way trip. So in infrared light, Planet 9 would only be about 100 times fainter. That's why it makes more sense to look for it using space-based infrared telescopes. And that's the idea behind this new study. The team started digging through archives, searching for old infrared sky survey data, and they pulled it from two main sources. First, IRIS, a satellite launched in the 80s that scanned the sky for almost a year. Then, the Japanese satellite Akari, another infrared observatory that operated between 2006 and 2011. So basically, they compared objects that showed up in IRIS database and noticed which ones had moved by the time Akari took its observations. And by doing that, the researchers found something incredible, an object that might just be our long-lost ninth planet. Because if something moves, it could be a planet orbiting the Sun, right? And yeah, they did find some celestial objects showing tiny movements. But before jumping to conclusions, they had to rule out the parallax effect. And that's something really important when we're talking about solar system discoveries. To explain it, I need you to do something. Hold one finger in front of your face. Close one eye, and now switch. Your finger seems to move a tiny bit, right? That's because you're looking at it from a slightly different angle, from one eyeball to the other. The same thing happens when we look out into space from Earth. Since our planet orbits the Sun, our view of very distant objects shifts just a little. That effect is called parallax. My point is, because of this effect, Planet 9 would appear to move across the sky as Earth goes around the Sun. On any given day, it might seem to be in one spot, but 6 months later, when Earth is on the opposite side of the Sun, it would look like it shifted. 6 months after that, it would seem to move back again. Scientists had to account for parallax. Actually, they had to remove its effects. So the team looked at images of the sky taken on the same date every year. Because on that same date, Earth is always in the same spot in its orbit. That means if Planet 9 is real, it would show up in the same place in those images every year. No fake wiggle from parallax, just its real position. This careful search led them to a single object, a tiny dot in the infrared data. This strange little spot had moved slightly along its orbit around the Sun over the 23 years between Iris and Akari. Wait, could that be it? Did astronomers just confirm a hidden planet? Well, maybe. But don't get too excited. The data we have on its motion over that time is not enough to figure out its full orbit. So, for now, we still can't say for sure if this mysterious object is really Planet 9. It's definitely a strong candidate, though. Based on how bright the object appears, the team estimates it could be pretty massive, and that came as a big surprise. You see, previous NASA research ruled out any Jupiter-sized or Saturn-sized planets hiding out there, but a smaller world would have gone undetected. So the scientists were looking for something just a bit bigger than Earth. But it turns out this mysterious planet might be more massive than Neptune. Now that they discovered Planet 9, supposedly at least, the plan is to keep tracking it and collecting new data. But don't think the road ahead will be easy. Because since the Akari satellite spotted it for the first time, that object didn't just sit still. It's been moving slowly through space ever since. So now scientists need to use regular telescopes on Earth to look for it again. And here's the tricky part. They're not exactly sure where it moved to, so they have to search a pretty big patch of the sky. And so far, no matching object has been found. Whether this really turns out to be the Planet 9 discovery or not, only time will tell. For now, its existence is still up for debate. But with powerful new technology on the way, like NASA's Nancy Grace Roman Space Telescope, astronomers are more determined than ever to uncover the truth. And if Planet 9 really is out there, hiding in the cold, dark edges of our solar system, it's running out of places to hide.
From planets with glass rain and oceans of lava, to worlds with 3 suns and giant diamonds, our universe is full of surprises. Sometimes we find celestial bodies that shouldn't even exist at all. But despite all logical reasoning, they live and thrive. In 2023, we discovered another impossible planet, TOI 5295b. Once again, our universe turns out to be much more complicated than we thought, and this isn't the only strange planet that we've discovered in recent years. So, let's take a look at a couple of these impossible planets. TOI 5205b is the first one on the list. This is an unusually large planet orbiting a small star. It's located about 280 light-years from Earth. It's quadrillions of miles, but on a cosmic scale, it's pretty close. This planet was discovered just recently, in 2023. So why is it so special? Because it doesn't follow the rules of planetary formation, like other planets in its neighborhood. TOI 5205b is a bit of a rebel because it orbits a tiny red dwarf star that's only 4 times larger than Jupiter. What's so weird about it, you ask? Well, you see, a red dwarf is basically like the runt of the litter in the world of stars. This type of star is rather cold, about 2 times colder than the Sun. They have a reddish tint, hence the name. And yep, stars work quite strangely. The closer they are to red, the colder they are, and the closer to blue, the hotter they are. Hey, I don't make the rules. Anyway, because of all this, they aren't very bright. So without a good telescope, you won't see them in the sky. But they aren't just some space losers. They're the most common stars in the universe. They also live much longer than our Sun, and thanks to this, they usually have a bunch of different planets orbiting them, including those similar to our Earth. So if one day we decide to find a new home, it may well be near some red dwarf. But here's the catch with TOI 5205b. It's a gas giant. Gas giants like, for example, Jupiter or Saturn, are the behemoths of the universe. These planets are mainly made up of gases like hydrogen and helium. They don't have a solid surface like Earth or Mars, so you can't exactly land on them without getting crushed by the immense pressure. And they're not called giants for nothing. They're absolutely massive. In fact, if you took all the other planets in our solar system and squished them together, they still wouldn't be as big as Jupiter. In other words, they're the gassy wrestlers of the planetary family. So, how is it possible that such a huge planet orbits such a small, weak star? Red dwarfs are usually considered too small to host gas giants. Moreover, it's physically impossible. Or at least, so we thought. But TOI 5205b had other plans and decided to form near a red dwarf anyway. It's like a small pea orbiting around a lemon, which doesn't sound that bad until you remember that Jupiter next to our Sun is like a pea next to a basketball. Only really big stars are able to keep such big planets nearby. This had astronomers scratching their heads as it went against everything they thought they knew about planet formation. And while we try to figure out how TOI 5205b managed to break the rules, the planet itself seems pretty content to blaze its path through the cosmos. And it isn't the only one. In recent years, scientists have discovered a bunch of such forbidden planets. So let's check out the other ones. For example, TOI 3757b, a giant planet with the density of a marshmallow. Imagine a giant planet that's so soft and fluffy it's like a marshmallow floating in space. That's right, TOI 3757b is a gas giant that's been dubbed the Marshmallow Planet because of its incredibly low density. Of course, it's not edible and cute like real marshmallows, but it would still be fun to touch it. This planet was discovered in 2022. It's located in the constellation of Auriga the Charioteer, 591 light-years from us. Just like the previous one, it's also orbiting around a red dwarf star. And get this, TOI 3757b only takes around 3 days to complete one orbit. Imagine having a birthday every 3 days. It's also incredibly close to its star, just some 3.5 million miles away. For comparison, the distance between the Sun and the planet closest to it, Mercury, is about 36 million miles. So TOI 3757b is like right on top of its star. Let's hope this marshmallow planet doesn't get too toasted. Now let's talk about how this planet was discovered. It was spotted by the Transiting Exoplanet Survey Satellite, or TESS, a space detective on the hunt for new planets. The transit detection method is when scientists use the star's light to find their planets. When the planet passes through the star, it blocks a tiny portion of the star's light, making it look a little dimmer for a while. Scientists can detect this dip in brightness using special instruments. If the dip happens regularly, they can tell that there's a planet orbiting the star. The size of the dip in brightness tells scientists how big the planet is and how close it is to the star. If the dip is really small, that means the planet is probably pretty small too. And if the dip happens more frequently, that means the planet is probably closer to the star. And this is how we discovered our Marshmallow Planet and many other ones. Overall, TOI 3757b is a fascinating planet that's captured our imaginations with its unique properties. Now, let's move on to the next mysterious celestial body. TYC 8998-760-1b on the border of a planet and a star. Whew, that was a mouthful. Let me introduce you to a planet whose name I won't repeat. Well, this baby is also a gas giant, but not just any gas giant. In fact, it's so big it could make Jupiter feel like a tiny pebble in comparison. I mean, it's 14 times the mass of Jupiter and 3 times as big around. Isn't that impressive? It orbits a very young, sun-like star 300 light-years away. This star is only 17 million years old, and yes, it's considered a baby among the stars. For comparison, our own Sun is about 4.5 billion years old. But the star itself isn't that interesting. The planet, on the other hand, is a bit of a weirdo. You see, planets just can't be that big. With its enormous mass, it should be a star. It's kind of like the Caspian Sea, which is considered the largest lake in the world. Just as the Caspian Sea isn't really a sea or a lake, this planet is the middle child of the universe. Not quite a star, but not exactly a planet either. Some scientists think that it might be a failed star, which is like saying a cake that didn't rise properly. And let's talk about its temperature. You know how you feel like a baked potato when it's 90 degrees Fahrenheit outside? Well, this planet laughs at us. Its estimated surface temperature is a whopping 2,600 degrees Fahrenheit. That's hotter than a jalapeno popper straight out of the fryer. This time, the planet was discovered by the imaging detection method. You see, capturing pictures of exoplanets is no easy feat. The star is always way brighter and ruins the pic. It's like trying to take a selfie with your crush while your annoying little sibling is jumping up and down in front of you. But scientists have a solution. They use some specialized optics and clever observation methods, like coronography. They basically block out the light of a star so that we can see the planet more clearly. Magic, right? And that's how they discovered this not-a-star planet too. And now it's giving scientists a lot to think about. It makes us question what we know about the formation of planets. Let's hope we'll find out more about it in the future. It's amazing to think about the weird and wacky things that exist in our universe, and these planets definitely fit the bill. Who knows what else is out there waiting to be discovered? Maybe someday we'll find a planet that's even more impossible than the ones we just discussed. Until then, keep your eyes on the skies and your mind open to the infinite possibilities of our universe.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the Moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our Sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
Attention, Earthlings! Yes, that would include you. Scientists have discovered a new member of the solar system. We officially have a new dwarf planet orbiting well beyond Neptune. But that's not all. Despite being small and unremarkable, this object, called 2017 OF201, I know it's a goofy name, might hold the key information about the speculated existence of Planet 9. Or, better said, it spoils the fun because instead of helping us find Planet 9, it could be the first tangible evidence that the theoretical ninth major planet was just that, a theory. But first, what exactly are dwarf planets? And why is this discovery so important? Well, in the early 21st century, researchers gained better telescopes and began discovering smaller, weirder celestial objects. It started with Eris in 2003, but the discovery of additional similar bodies led to Pluto losing its status as a, quote, true planet. To proudly carry the name of a planet, a space rock must check off 3 boxes. It must orbit the Sun, not another planet, like a moon would. It must be massive enough for its gravity to make it round. And it needs to be gravitationally dominant in its orbit. In other words, an object should be able to clear out most other objects in its path by absorbing them, slinging them away, or influencing them in some other way, like paying them off. Hey, just kidding. Imagine a giant, powerful truck driving in its own lane, pushing smaller cars aside. Hey, sounds like my commute. Although Pluto is orbiting the Sun and has the needed elliptical appearance, it's in the Kuiper Belt, a region full of icy objects. Because it can't clear its orbit, researchers realized that Pluto was not that different from many other similar bodies known as trans-Neptunian objects or TNOs. There are well over 5,000 known TNOs out there, with only 1,000 being officially numbered, meaning they've been studied enough to have their orbits confirmed. Now here's where it gets interesting. A while ago, scientists noted a pattern. Many of these minor planets shared similar paths and tilts. This inspired a theory that those objects were influenced by some still undiscovered Planet 9, also known as Planet X. The proposed super-Earth would have a mass 5 to 10 times greater than Earth's. It would orbit far on the outskirts, possibly as far as 500 astronomical units, and like an invisible puppeteer, manipulate the orbits of TNOs with its gravity. Some of these objects get classified as extreme trans-Neptunian objects. Let's just call them ETNOs for short. ETNOs are minor planets with an average distance of at least 150 astronomical units from the Sun. They have eccentric orbits, which can't be explained by the gravity of Neptune, Uranus, Saturn, or Jupiter. This led some scientists to conclude that Planet X must be out there. Ooh. As the years went by and more TNOs were discovered, Scientists began to notice that those newly found objects didn't follow the previously established patterns. Many TNOs and ETNOs discovered in the last 5 to 6 years didn't match the same orbital parameters. Of the 6,000 objects found orbiting beyond 30 AU from the Sun, many show no signs of being influenced by a hidden planet. Well, despite that, scientists still hesitate to admit that Planet X is just wishful thinking. Not only is discovering something new exciting, but a planet like that could also protect us by pulling in asteroids from deep space. It could help explain why our solar system looks so different from many others, where super-Earths and mini-Neptunes are common. It might even solve how the solar system was formed, how objects got scattered, and what's still hiding in the dark. Discovering Planet 9 wouldn't just be cool, it could reshape everything we know about the solar system. However, with the discovery of 2017 OF201, actually that's still a mouthful, let's call it Ophy from now on. With the discovery of Ophy, the whole Planet 9 theory seems to be on its last legs. So, what makes Ophy so special, and how does it affect the idea behind Planet 9? The newly discovered member of our solar system is estimated to be about 430 miles in diameter. This places it in the dwarf planet category, certainly larger than many other trans-Neptunian objects, but still about 1/3 the size of Pluto. What stands out most is its elongated orbit around the Sun. It takes at least 25,000 years to complete one revolution. Its orbit brings it as close as about 45 astronomical units from the Sun, which is similar to Pluto's distance, and extends out as far as 1600 AU at its most distant point. This means it travels far beyond the Kuiper Belt and approaches the inner boundary of the Oort cloud. This orbit is not just extremely long, it's also highly eccentric, stretched out like a long oval. This puts it in a rare group of objects that travel to the most distant parts of our solar system. While there are objects with longer orbital periods, like comets that originate from the Oort cloud, they're much smaller than this newly discovered dwarf planet. But despite its relatively large size for such a distant object, Ophy is nearly undetectable. It spends most of its time hidden from Earth's view, far from the inner solar system and too faint for current telescopes to spot. In fact, astronomers estimate it's only visible for about 1% of its 25,000-year orbit. In fact, this new dwarf planet came closest to the Sun in 1930, the same year Pluto was discovered, yet it slipped away unnoticed. Nobody spotted it back then, and it only got discovered in May 2025 completely by accident. By digging through archived data from publicly available telescopes, researchers pieced together its location from 19 separate images taken over 7 years. That's impressive detective work. So, what does all of this mean for Planet X? The archive photos have revealed that this object's orbit does not match any of the orbital clustering previously used to support the Planet 9 hypothesis. It doesn't belong to the same group as other ETNOs, and, more importantly, if a hidden planet is really tugging on celestial bodies, Ophy should have been flung out of the solar system millions of years ago. If Planet 9 was where we speculated and had the predicted mass, then Ophy's current orbit wouldn't last. It would likely be altered or even destroyed within about 100 million years. However, its orbit appears stable and undisturbed, suggesting it has been like this for far longer. But wait, you exclaim. If the mysterious orbit of Ophy is not caused by an invisible giant planet, what else could it be? Well, space is full of surprises, and gravity isn't exclusive to planets. One idea is that the orbit has been stretched over time by galactic tides. Just like the Moon pulls on Earth's oceans, the Milky Way galaxy itself pulls ever so gently on everything in the solar system. It's a slow, steady force. But if you're far out enough, like Ophy is, even that gentle tug can twist your orbit over millions of years. Now, another possible explanation could be that a passing star may have come to our solar system a long time ago, especially during its formation. Back when the Sun was young and surrounded by newborn stars, one could have passed close enough to give some outer objects a gravitational nudge. That kind of flyby could have easily yanked an icy object into a stretched-out tilted orbit. The third idea is that such unusual orbits are leftovers from the early solar system, when planets and debris were being flung all over the place. Some may have ended up in stable but extreme orbits, like Ophy, the dwarf planet. If something really is pulling on these distant objects from outside our solar system, something like the galaxy itself, then we lack models to explain it. It's remarkable that we've managed to spot Ophy in the first place. These objects only appear when close to the Sun, so we've likely seen just a fraction of what's out there. There could be hundreds or even thousands of similar rocks, all with strange orbits and mysterious origins. Which means the real mystery might not be a hidden planet, but the hidden world of space rocks quietly orbiting in the dark, waiting to be found.
Have you heard about Planet 9? No, not Pluto. We're talking about something lurking on the outskirts of the solar system. A mysterious planet that exists in our solar system that we haven't yet discovered. We've been looking for it for years, but finally, it seems like scientists found a key to solve this mystery. Planet 9 is a hypothetical planet. Astronomers have been on the hunt for it for quite some time now. But it's so elusive that they've only been able to piece together a few details about its potential characteristics. One thing we do know is that Planet 9 has to be a massive world, possibly up to 10 times the mass of Earth. That's one big planet. It's also thought to be a distant wanderer, hanging out somewhere between Neptune and Pluto. Some scientists think that Planet 9 might actually be a mini Neptune, with a thick, gaseous atmosphere and a rocky core. Others speculate that it could be an icy world with a solid, frozen surface and a thick layer of hydrogen and helium gas. Of course, since we haven't actually found Planet 9 yet, we can't say for sure what it's like. We're not even sure that it even exists. Some say it's just a myth, like the Tooth Fairy or the Easter Bunny, but others are convinced that it's out there somewhere. And at the end of the day, we're not entirely sure if Planet 9 is even a planet. It might be a special kind of black hole or made entirely of dark matter. The search for Planet 9 began in the early 21st century when a group of astronomers realized that something wasn't quite right with the outer reaches of our solar system. They noticed that some distant objects, known as trans-Neptunian objects, were behaving in unexpected ways. Trans-Neptunian objects, or TNOs, are like the cosmic version of those items in the back of your fridge that you forgot about for years. They're small, icy bodies that hang out in the Kuiper Belt, beyond Neptune. So, scientists noticed that these guys started behaving weirdly. At first, they thought it might be a fluke. But as they dug deeper, they began to suspect that there was a ninth planet lurking out there. Why haven't we discovered it yet, you ask? Well, it may be because of Planet 9's weird orbit. All the other 8 planets orbit the Sun in roughly the same plane, which is like a flat disk. However, our hypothetical friend's orbit is different. It might be tilted and move in a different direction compared to the other planets. Its orbit might also be stretched out like an oval, rather than being nearly circular like usual. Because of this, Planet 9 might spend most of its time far from the Sun, like a true introvert. It only comes relatively close to the inner solar system every few thousand years. This would make it super faint and hard to spot. So the only way we may discover it is by studying the gravitational effects it has on our solar system. And this isn't the first time astronomers have gone looking for a new planet. Back in the 19th century, there was a similar hunt for a hypothetical Planet X. But this time, they were armed with much better technology and a much better sense of humor. They began calling their elusive quarry Planet 9, which was much catchier than Planet X. They even came up with a hashtag for the search, Pluto Lives. It was a reference to the fact that Pluto had been kicked from the planet gang and some astronomers were eager to find a new planet to take its place. But the search for Planet 9 has been no easy task. It's like trying to find a lost sock in the laundry basket the size of a football stadium. It's so far away and so faint that even the most powerful telescopes can't see it. Instead, astronomers have had to rely on indirect evidence, like the strange orbits of TNOs, to try to figure out where it might be. Some scientists have even supposed that it might be a wandering rogue planet, which would explain why it's so hard to find. But they haven't given up hope. Till this day, they're scouring the skies using all sorts of high-tech telescopes and fancy algorithms to try and spot this elusive planet. And fear not, dear curious human, because it looks like after so many years of research, we may have finally found the key to solve this mystery. Astronomer Man Ho Chan from Hong Kong has a theory. He believes that Planet 9 could have a bevy of moons. That's right, not only is it a giant planet hiding out in the depths of space, but it's also a bit of a hoarder. Moons are all the rage in the outer solar system. In fact, almost every planet here has at least one moon, except for Mercury and Venus. Earth has just one, which is kind of sad if you think about it. Even non-planetary bodies like Pluto have at least a couple of moons. A bit unfair, isn't it? Anyway, taking this into account, let's go moon picking with Planet 9. The region between the rock-filled Kuiper Belt and the rock-filled Oort cloud, where this planet is predicted to be, should be ripe for the picking. Chan made some calculations and determined that it would be stranger if the elusive planet didn't have any satellites. According to his calculations, an object the mass of Planet 9 should capture at least 20 TNOs as large as almost 90 miles across. It's like our mysterious planet is playing cosmic Pokemon with these guys. So, what if Planet 9 has moons? Would that make any difference? Kinda yes. They could give us some indirect clues to finally locate this mysterious planet. Now, you might be thinking, how in the cosmos can we possibly spot these teeny tiny moons? It's not like they're going to wave a giant flag or blast some Beyoncé tunes to get our attention. Well, apparently the key lies in something called tidal heating. Tidal heating might sound like a new workout trend, but it's a real scientific phenomenon. It happens when two celestial bodies are close together. You see, tides aren't just about the rise and fall of the ocean, they're also the result of gravity pulling unevenly on a planet or moon. When a planet and a moon are close enough to each other, their gravity pulls on each other, creating a bit of a football shape. And as these celestial bodies move around each other, they shift shape and generate friction inside, which produces heat. Wow, who knew that Planet 9 could have a workout routine? Perhaps we should start calling it Gym Planet instead. Anyway, if Planet 9 has any moons, the gravitational pull from these moons would cause it to change shape constantly, generating heat in the process. And we might be able to detect this mysterious planet through the heat produced by those moons, even though it gives off no other signals. Now, before you get too excited, finding them won't be a walk in the park. They're incredibly small and would be very far away from us. But hey, nothing worth discovering ever came easy, right? Scientists are optimistic that with the right technology, they can spot this telltale sign. It will be easier for us to spot them with fancy instruments like modern telescopes. Talk about cool friends to have, right? Sure, the process of finding it may be difficult and time-consuming, but the potential payoff is huge. Finding this planet could explain a lot of the strange behavior observed in TNOs, the Kuiper Belt, and beyond. As we've already mentioned, they've been acting super weird lately, tilting and aligning in suspicious ways. If this planet doesn't actually exist, we have yet to explain what is the reason for this strange behavior. In any case, the search for Planet 9 is one of the most exciting and intriguing quests in modern astronomy. It's like a cosmic scavenger hunt, and everyone's invited to join in on the fun. So, grab your telescopes and let's go planet hunting. Who knows? Maybe we'll find it sooner than we think.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the fifth largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet. Now picture a strange world where molten metal falls from the sky, a planet where it rains glass sideways, a place where the winds are many times the speed of sound. Even though these planets sound like stuff from a nightmare, they do exist. Would you survive on any of them? Nope. But come on, let's see why. Now brace yourself, and I mean it literally, because WASP 127b is terrifyingly windy. On Earth, our most powerful storms produce winds around 200 miles per hour. And even Neptune, the windiest planet in our solar system, tops out at about 1,100 miles per hour. But on 127b, winds dash across the equator at a staggering 20,500 miles per hour. That's 35 times faster than a jet and faster than the speed needed to orbit the Earth. 127b orbits a star similar to our Sun, but it's super close to its parent star, only 4.3 million miles away. That's why it takes just 4.2 days to make a full orbit. The heat there is insane. Cloud tops reach 1,800 degrees Fahrenheit, which is enough to melt almost, anything. And 127b is supermassive. Well, kind of. It's a gas giant with a diameter 1.3 times that of Jupiter, but only 1/6 of Jupiter's mass, which makes it a giant, hot, puffy balloon floating in space. The planet's atmosphere is so expanded that it's basically a boiling, raging storm globe, completely unlivable. If you somehow ended up on 127b, survival would be, impossible. The winds would toss you around, the extreme heat would cook you, and the planet itself would offer no solid ground to stand on. You wouldn't be able to breathe, move, or survive even for a second in these extreme conditions. But shockingly, that's not the worst planet you could land on. Imagine a world where it literally rains iron. This is WASP 76b, a planet so close to its star that the day side scorches at over 4,300 degrees Fahrenheit, hot enough to vaporize metals into gas. The night side is cooler, but still a blistering 2,500 degrees. Such a temperature makes those metals condense into clouds and rain down, like molten malted milk balls falling from the sky. The planet orbits its star every 43 hours, and it's tidally locked, which means that one of its sides always faces the star. The winds on the planet are absolutely insane, blowing up to 11,200 miles per hour. They zoom across the planet, fueled by the extreme temperature difference between day and night. And 76b is huge. It's a gas giant twice the size of Jupiter. It's practically sitting on the edge of its star's outer atmosphere. Scientists say we don't fully understand the physics here. Eventually, this planet could spiral into its star, or radiation could strip away its atmosphere, leaving only a scorching rocky core. Now, a human on 76b wouldn't last a fraction of a second. The day side would instantly vaporize you, just like the night side. And don't forget about the winds. You'd be ripped apart before you even touch the ground. And iron rain would slam down around you like fiery pellets. Sounds like a place to avoid. Now, if you're looking for long-term real estate investments, avoid WASP 12b. This planet is over 1,300 light-years away in the Auriga constellation. It orbits its Sun-like star extremely closely, completing one orbit in just over one Earth day, about 26 hours. The planet's surface temperature reaches nearly 4,600 degrees Fahrenheit. It is 40% more massive than Jupiter, but powerful tidal forces stretch it into a football shape. But the main problem is that the atmosphere of this planet has expanded to nearly 3 times Jupiter's radius and is being pulled onto the star. And that means the planet is slowly being destroyed. Astronomers think that in about 3 to 10 million years, the planet could be gone for good. They found a huge cloud of stuff flying off the planet, including chemicals never seen on other planets before. No one would survive on 12b. The surface temperature is hotter than molten lava or any furnace on Earth. Any protective suit would fail instantly. The atmosphere is being ripped away by the planet's star, so there's no breathable air, just superheated hydrogen and helium streaming away into space. Plus, the gravity is extreme, so moving there would be, impossible. In any case, you would be vaporized almost instantly before trying to take a step. But however bad this planet sounds, the next world on our list beats it, because it rains glass on this planet. HD 189733b, I'll just nickname it Bubba, is a truly terrifying place, just 64.5 light-years from Earth. It's a gas giant, slightly bigger than Jupiter, and about 11% wider. But don't let that fool you. This world is a nightmare. Winds roar across the planet at up to 5,400 miles per hour, which is about 7 times the speed of sound. Temperatures soar between 1600 and 2200 degrees Fahrenheit, hot enough to melt metal. The planet also spins incredibly fast, completing one orbit in just 2.2 days. It races around its star at roughly 341,000 miles per hour. Its cobalt blue color comes not from water, but from a scorching, hazy atmosphere filled with silicate clouds. These clouds can condense into glass, and the planet's hurricane-force winds likely fling it sideways, making the rain fatal. Bubba is a hot Jupiter, a huge gaseous planet racing in a tight orbit around its star. It's also one of the most extreme, hostile worlds astronomers have ever found. If you somehow ended up in this world, survival would be out of the question. The heat alone is lethal. Insane winds would slam you around. An umbrella wouldn't save you from glass raining sideways, which would shred you in seconds. In short, you wouldn't last a heartbeat in this inhospitable world. But there's a planet that makes almost every other world look tame. It's Gliese 436b. It's small for an exoplanet, roughly the size and mass of Neptune, but don't let that fool you. Its proximity to its star turns it into one of the most extreme planets we know. 436b orbits a red dwarf star just 2.5 million miles away. To put that into perspective, Mercury, the closest planet to our Sun, is nearly 36 million miles out. This means that 436b races around its star every 2 days and 15.5 hours. That's lightning fast. A year there is shorter than a long weekend on Earth. The surface temperature is a balming 820 degrees Fahrenheit, which doesn't sound too bad in comparison. But there's the twist. The planet is covered with ice. Now, that's not ordinary ice, though. This is Ice 7, a dense, crystalline form of water created under unimaginable pressure. Imagine water so tightly packed that instead of melting under extreme heat, it remains solid. Scientists call it burning ice, and it's a form of ice that Earth laboratories can only replicate under controlled conditions. The atmosphere of the planet is just as bizarre. The planet is mostly hydrogen, like a gas giant, but it contains 7,000 times less methane than expected. Instead, astronomers find a surprising amount of carbon monoxide, which shouldn't survive in such heat. To make it even stranger, 436b is losing its atmosphere. The planet is wrapped in a huge cloud of hydrogen, probably pushed out by the strong gravity from being so close to its star. This cloud is 50 times bigger than the star itself. Unlike a comet's tail, it doesn't get blown away. It follows the planet. Astronomers think that 436b has already lost up to 10% of its atmosphere. Now, if a human, like you, somehow landed on Gliese 436b, survival would be impossible from the first second. The surface temperature is hot enough to vaporize skin and incinerate anything exposed. The gravity is crushing because the planet is dense and packed tightly with matter, which would make a person feel like trying to lift a car with every step. Even worse, can it get worse? Yes. The atmosphere is mostly hydrogen with high levels of carbon monoxide. Breathing would be instantly toxic, and a single inhale would shut down your lungs. And that burning ice is so solid under pressure that even if you somehow avoided the heat and toxic air, the ground itself would be a strange, brittle, crystalline surface that could fracture or collapse underfoot. Add to that the planet's rapid orbit. Completing a full year so fast means winds and atmospheric currents are extreme. No shelter, no suit, and no parachute could protect you. In short, you would be instantly boiled, crushed, and poisoned, all while the strange, dense ice underfoot refuses to melt. Well, bye-bye. Let's see, there's Mercury, Venus, Earth, Mars, Phaeton, Jupiter. Wait, hold on. What Phaeton am I talking about? Well, let's see. It was the beginning of the 19th century, and the asteroid belt hadn't been discovered yet. In the year 1801, one man named Giuseppe Piazzi spotted the largest asteroid in the solar system, Ceres. At that time, people believed that there was a planet orbiting between Mars and Jupiter, and Ceres seemed to fit the bill. But the next year, another astronomer, Heinrich Olbers, found one more space body following a similar orbit. It was an asteroid which was later called Pallas. This discovery helped Olbers to figure out that these two space objects could be fragments of a planet. The discovery of two more asteroids, Vesta and Juno, seemed to confirm this theory. It was believed that the planet, which was named Phaeton in the 20th century, appeared in the early days of the solar system and was later destroyed, and its debris formed the asteroid belt. Olbers' idea was called the disruption theory. To astronomers at that time, it seemed obvious that the planet once collided with a large space object, which led to its demise. The most likely candidate was Nemesis, a hypothetical red or brown dwarf orbiting our Sun. Another theory claimed that Phaeton could have gone through an internal cataclysm, which could have broken the planet into pieces. There was one more idea: Phaeton could have come too close to Jupiter and got torn apart by the gas giant's immense gravity. These days, though, astronomers don't believe in the disruption theory anymore. A new idea has replaced it. It's known as the accretion theory. It claims that the asteroid belt is all that is left of the protoplanetary disk. Supposedly, this disk had been originally orbiting the Sun, even before the planets formed. Unfortunately, because of Jupiter's gravitational forces, it never managed to coalesce into a planet. But what is this asteroid belt we keep talking about? This region is located between the orbits of Jupiter and Mars. Tons of asteroids and even minor planets are found there. Some of them can sometimes migrate or even get thrown out of the asteroid belt to the outer solar system. The four largest asteroids in that area are Ceres, Vesta, Pallas, and Hygeia. They make up half the mass of the entire belt. As for the rest of the mass, countless smaller bodies make up for it. In loads of sci-fi movies about space, the main character gets into an asteroid belt and has to try hard to get away from countless rocks threatening to smash their spacecraft. Well, it has nothing to do with the real thing. Even though there are thousands of asteroids in this region, they're so widely spaced that the chance of collision is next to nothing. Hey, but it's a movie, right? Anyway, when the asteroid belt was forming, some objects started to come together and form what we know as protoplanets. But the gravitational pull that was caused by the formation of Jupiter made such collisions too rough, and instead of forming large space bodies like planets, asteroids shuddered. Astronomers think that as a result of such collisions, more than 99.99% of the original mass of the asteroid belt was lost in the first 100 million years of the history of the solar system. Only the largest asteroids have enough gravity to get a spherical shape. Small ones are just often piles of rubble, loosely held together by gravity. And the tiniest objects in the asteroid belt resemble dust, so small they are. And all these objects, giant and tiny, orbit the Sun. There are several types of asteroids, depending on their composition and albedo, which is the proportion of light or radiation reflected by a surface. The main types are carbon asteroids, which have a very dark surface, silicon ones, you can also call them stone asteroids, and metal ones. The first two types account for around 75% and 17% of asteroids that we know about. For the first time, the asteroid belt was crossed by a spacecraft in 1972. It was the Pioneer 10 space probe. The spaceship managed to refute the theory that the belt was filled with dust that could easily damage all gadgets on board. It didn't happen. And since that time, 8 more probes have traveled through the asteroid belt. And now, I'm going to tell you some cool facts about the solar system itself. Try to count how many of these facts you've known before and write your answer down in the comments below. The solar system is a staggering 4.5 billion years old. Scientists came to this conclusion after studying meteorites, the oldest material they managed to find. But our solar system isn't the only one in the Milky Way galaxy. The galaxy we live in houses about 100 billion star systems. And if it's just our galaxy alone, what can we say about the whole universe? Now, our Sun is also insanely massive. Here's the proof. 99.86% of all the mass of the solar system is the mass of the Sun, in particular hydrogen and helium that it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Oh, by the way, contrary to popular misconception, outer space isn't a perfect vacuum. It contains not only stars and planets, but also clouds of interstellar dust, space plasma, and cosmic rays. Those are atom fragments dashing from the outskirts of the solar system. Now, one phenomenon astronauts should worry about while exploring space is cold welding. If two pieces of the same kind of metal touch in space, they bond and get permanently stuck together, kind of like galaxy glue. It doesn't happen on Earth since water and air keep pieces separate. You can see solar eclipses even though the Moon is 400 times smaller than the Sun. It's also 400 times closer to Earth, so it's perfectly capable of obscuring the star. But in 600 million years, the Moon won't be able to block the Sun completely because of the satellite's changing orbit. Behind the orbit of Neptune, there is the mysterious Kuiper Belt, filled with massy icy objects. The most curious thing about this space formation, though, is that the scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. The ocean on Jupiter is larger than any body of water on other planets of the solar system. But it's not the ocean you think about. The one on Jupiter isn't made of water. This mesmerizing thing consists of metallic hydrogen, and its depth is around 25,000 miles, which is actually almost the same as the circumference of Earth. Now, people got to know about beautiful Saturn's rings in the 1600s, but now we know that Saturn isn't the only ringed planet. All the giant gas planets, Uranus, Neptune, and Jupiter, have rings of their own, but they're thin and almost impossible to see. As for Mars, Venus, and Earth, they're made of rocky material and have no rings. At the same time, Saturn's moon Rhea might have a ring system consisting of 3 narrow bands. If astronomers manage to confirm it, it'll be the first time for people to discover rings around a moon. Oh, and Mars might get a set of rings of its own in the next 70 million years. The red planet's largest moon, called Phobos, is orbiting closer and closer to the planet. One day it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. And another cool fact about Mars. You've probably heard of methane gas, a byproduct of such natural processes as volcanic activity and cow emissions. Anyways, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be life on Mars? Can there be cows on Mars?
Look at this giant donut-shaped region far away from Earth, beyond the orbit of Neptune. We're talking about a distance of more than 2.5 billion miles. It's the Kuiper Belt, and something eerie and bizarre is happening there. Dwarf planets and other small objects dwelling there refuse to cluster together. Instead, they follow particular orbits, which is weird. The reason might be a large, mysterious planet hiding beyond Pluto. Its gravity might be messing up the orbits of those Kyper space bodies. Hear me out. Our solar system is made up of the Sun and everything that goes around it because of the star's strong gravity. This includes the 8 main planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are also smaller things like moons, asteroids, and Pluto. For a long time, people thought Pluto was the 9th planet, but when it was reclassified as a dwarf planet, scientists started looking for a new Planet X. Did they have a thing about odd numbers or what? And guess what? some really think there might be a big, icy planet hiding far, far away beyond Neptune. This mystery planet is often called Planet 9. Now, Planet 9 hasn't been seen yet, but scientists think it might be out there because of some tiny, faraway space rocks called etnos that move following bizarre, confusing paths. These paths seem to be grouped together and tilted in a way that doesn't happen by chance. This could mean there's a hidden planet pulling them into place with its gravity. If Planet 9 is real, it might be 5 to 10 times heavier than Earth. It would also be super far away, hundreds of times farther from the Sun than Earth is. Over the years, scientists have guessed different distances for its orbit, and the newest guess in 2025 says it could be about 290 times farther from the Sun than Earth. There are some cool ideas about where Planet 9 came from. It might have started as a big planet that Jupiter once kicked out of the inner solar system, or it might have come from another star or even wandered around space on its own before getting caught by the Sun's gravity. Even though scientists have looked really hard using powerful telescopes, no one has actually seen Planet 9 yet, and so far, its existence is still just a theory. But recently, a group of researchers tried something clever. They used data from two special space surveys called IRAS and ACARI. These two looked at the sky in invisible light, far infrared, about 23 years apart, which is helpful because Planet 9 is supposed to move very slowly. The team focused on a special list from ACARI, which is better at finding faint, moving things in space. They guessed how bright Planet 9 might be and how fast it might move based on how big, far away, and cold it could be. Then they looked for matching blips in the sky that were seen by both IRAS and ACARI, but not in the exact same spot. That's because a real planet would have moved a little over 23 years, and they indeed found 13 possible matches that could be Planet 9. Their estimations were based on how far away the object seemed to be, 500 to 700 times farther from the Sun than Earth, and how heavy it might be, which is 7 to 17 times Earth's mass. After looking very carefully at all the images, they narrowed it down to one really good candidate. The two detections weren't in the same spot in both surveys, and the way they appeared in the ACARI map matched what you'd expect from a slow-moving object. It showed up on one date and wasn't there 6 months earlier, but of course, there was a catch. Apparently, the old data isn't good enough to figure out the exact path of the potential planet. So, the team wants to do new follow-up observations using a special camera called DCAM, which is really good at spotting faint, moving objects. That way, they can find out if this candidate is really Planet 9. Additionally, it can help us learn more about how our solar system works and how it formed. If Planet 9 is ever discovered, it would totally change the way we understand our solar system. It could explain why some far-out space rocks in the Kuiper Belt tilt weirdly. The thing is, most planets go around the Sun in a flat-ish circle, but those faraway objects are tilted about 20 degrees. Planet 9 might be the reason why. Next, we'd probably find out why those tilted objects seem to point the same way. Their orbits are grouped together in one direction. A big hidden planet's gravity could be hurting them like sheep. There are also some strange tilted objects super far away. They don't make sense unless something big, like Planet 9, is tugging on them. A few space rocks orbit the Sun backward between the big planets, which is kinda the wrong way. That's super weird unless something big is messing with them. Some far-out Kuiper Belt objects keep crossing Neptune's path and haven't been flung away. That's because Planet 9 might be helping keep their orbits stable over a long time. Another cool thing is that if Planet 9 existed, it would be a super-Earth, a kind of planet we see a lot around other stars, but we don't have in our solar system yet. So finding one here would make our solar system more like the others out there. Throughout history, people have been wondering if there could be hidden planets far beyond Neptune. even before Pluto was found. Back in 1880, a guy named George Forbes guessed there might be two unknown planets way out there, one about 100 times farther from the Sun than Earth, and the other about 300 times farther. He thought these mystery planets might be pulling on some comets and changing their orbits, kind of like how Jupiter does with the comets near it. In 2004, scientists found a weird little world called Sedna. It had a strange path around the Sun that didn't seem to be affected by any of the known planets. Its closest point to the Sun, called perihelion, is way too far for Neptune to be the reason. This made some scientists wonder if Sedna got pushed into its path by a hidden planet, maybe even something as big as Earth or bigger. Others thought maybe it was a star that flew by a long time ago, or another star that formed near ours. Then, in 2014, another odd object was discovered. It had a very similar orbit to Sedna, which made people even more suspicious that there could be something big out there messing with their paths. This kicked off a new round of the Planet X or Planet 9 hunt. At a meeting in 2012, a scientist named Rodney Gomez said that maybe there was a big, hidden planet around 1,500 times farther from the Sun than Earth. He thought it could explain the orbits of other odd objects, like some far-out comets and centaurs, small bodies that wander among the giant planets. At that time, those who supported the Planet 9 theory believed that if it existed, it would move around the Sun in a huge, stretched-out circle called an elliptical orbit. It would be about 400 to 800 times farther from the Sun than Earth is, about 13 to 26 times farther than Neptune. If it really had that kind of orbit, it would take around 10,000 to 20,000 years to go around the Sun just once. Plus, if it indeed orbited the Sun, it wouldn't follow the same flat path as the other planets. Its path would be tilted by about 15 degrees to 25 degrees. The farthest point in its orbit, called aphelion, would be in the direction of the Taurus constellation. As for the closest point, it would point towards Serpens, Ophiuchus, or Libra. As for the composition of Planet 9, it would probably be a lot like Uranus or Neptune. It would have a thick atmosphere made of hydrogen and helium, and it would be super cold, negative 375 degrees Fahrenheit. Its core would be made of iron, and its middle layer would be full of rock and water ice. At the same time, if the planet was smaller and denser, then it might be more like Earth, with a rocky surface instead of a gassy one. According to a scientist named Mike Brown, if Planet 9 was real, a space probe would reach it in about 20 years if we used a powerful slingshot path around the Sun.
Imagine a planet with no sun. Once it became unwanted in its own star systems and got ejected into the soulless emptiness of space. Or maybe it didn't even have its own star system. It was born lonely. I'm talking about a rogue planet. Such planets are also called orphans, nomads, unbound, and sunless. It all sounds pretty sad, doesn't it? The rogue planet in question doesn't have sunlight. The never-ending night reigns on its surfaces. No light means no warmth, and that's why there isn't any kind of life on this frozen world. But believe me, this isn't the scariest part. One day, a rogue planet might push Earth out of its cozy spot near the Sun. You see, we live in the habitable zone of our star. It means that our planet is such a distance from the Sun that water can't exist on its surface in its liquid form. But an interstellar intruder could mess it up for us. If a rogue planet somehow got into our solar system and we didn't manage to stop its imminent approach, it would likely crash into our beautiful blue planet. And then Earth could be pushed out of its orbit, retreating to an extreme orbit farther from the Sun. Now let's imagine what would happen to our world if a rogue planet the size of Mars collided with us. Most likely, people would react with panic and desperation. We've had a few sad examples of space intruders wiping more than 3/4 of all life forms off the face of the planet. One more similar event would be devastating. The immediate impact, pardon the pun, of such a collision would be truly catastrophic. It would lead to massive losses of life and destruction of huge areas of the planet. At first, people would focus on rescue and recovery efforts, but soon it would become obvious that the world is beyond salvation. The climate all over the planet would start getting colder and colder. Plus, the farther our planet would be from the Sun, the weaker the star's gravitational pull on our planet would be. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Well, that's rather grim. But what if humanity had foreseen this catastrophe and prepared for it in advance? What would our life look like, and where would we live after the cosmic disaster? If, by the time of the collision, people had already established a colony on Mars, we would probably have some time to leave Earth and set off for the Red Planet. But would it even be possible to transform this distant world so that it became capable of supporting human life? Oh, and it would no doubt be an enormous feat. You see, Mars is an extremely dangerous place to us. If you somehow teleported there without any protective suit, the gas in your blood would instantly turn into bubbles, which is not good. Add oxygen deprivation, cold exposure, and radiation poisoning to the equation, well, you get the picture. But if a rogue planet destroyed life on Earth, we'd have no choice. We would need to create a stronger magnetosphere on the Red Planet to shield it from the Sun's ultraviolet radiation. For the same reason, Mars would need a thicker atmosphere too. Right now, the Martian atmosphere is almost entirely composed of carbon dioxide with tiny amounts of oxygen. This air is not suitable for people. For humans to live there comfortably, Mars would also need to be warmer. And if we managed to somehow warm the planet up, we'd also be able to release frozen carbon dioxide. At the moment, there are vast reserves of this gas at the Red Planet's polar caps and other areas. It would help the atmosphere to become thicker, making it possible for water to exist on the surface of the planet. Also, we would need some place to live. NASA has been experimenting with light inflatable habitats, but obviously it wouldn't be a long-term solution. At the same time, it's incredibly expensive to deliver building materials to Mars, especially if we were pressed for time, escaping our poor collapsing Earth. So instead of shipping prefabricated construction elements to the Red Planet, we could grow them right on its surface. We could achieve this with the help of fungi and cyanobacteria. They can produce tons of biominerals like calcium carbonate as well as biopolymers. They would be able to glue Martian rocky material covering bedrock into real building blocks. In other words, bricks on Mars would be growing on their own, and we'd only have to assemble them into different structures, like walls, floors, and even furniture. At the same time, such a young colony wouldn't be able to survive for more than a generation without getting more supplies from Earth. But, as you understand, this option would be unavailable. Then, maybe people would move to colonies located on numerous space stations located far enough from the impact event. In this case, we would be able to avoid the destruction. But such habitats would have to be large enough to support farming and medical facilities, power-generating factories, educational establishments, and many more. And it would be hard work to support such stations without necessary supplies, when a simple equipment breakdown could turn into an unsolvable problem. But let's imagine that our descendants decided to find Earth several thousand years later and succeeded. As you remember, our planet would have changed its position, hanging out way further from the Sun. Now, hopefully, Earth would have regained its magnetic field after the impact, as well as a little of its original atmosphere. But those who would return to Earth would need water, oxygen, and sufficient atmospheric pressure. And while the new pressure on the planet would probably be suitable for life, most likely there wouldn't be enough oxygen to support unaided breathing. To get a new supply of oxygen, people would need photosynthetic bacteria. Would we find any on the deserted planet? Probably yes. Most, or at least some bacteria would survive, maybe somewhere deep under the surface, maybe in the depths of the oceans if any remained on the planet. Tardigrades, the most indestructible animals on Earth, might also survive and greet people returning home. These tiny water bears can survive for up to 30 years without food, live in volcanoes, and even endure the vacuum of the cosmos. So these life forms, bacteria and tardigrades, could likely thrive and multiply without any predators to slow this process down. That's good to know, but what would we eat on the newly inhabited planet? Tardigrades are not a diet a person could live on. Well, we could still find some frozen seeds remaining on the planet, or we could keep them on our space stations. Earth's soil could be filled with nutrients remaining after the catastrophic events of the past. People would start planting seeds, trying to get used to the harsh conditions of life on the once deserted planet. And still, it would be better than soulless space stations. Luckily, a rogue planet is unlikely, not only to hit Earth, but even to come close to our planet. The appearances of such space travelers are extremely rare, and with how fast our technologies are developing these days, astronomers would spot such a large celestial object appearing in the neighborhood or even in the entire solar system. It would happen long before a rogue planet turned into a threat to our planet. If it got too close to us, we would use one of the methods developed to prevent asteroids from hitting the surface of the planet. There are quite a few. For example, a kinetic impactor. This technique requires hitting an asteroid to make it change its orbit until it's no longer a threat to our planet. Or we could use a gravity tractor asteroid deflection method. That's when a robotic probe meets a space rock, or in our case, a rogue planet, and accompanies it for a few months or even years. Over time, the spaceship's gravity starts affecting the space body, adjusting its trajectory. There's even spray painting celestial objects. I'm not kidding. Darker surfaces tend to reflect less light, while lighter reflect more. Toying with these features, we can make a rogue planet change its course. If we found enough paint to cover an entire planet, that is.
Some time ago, the James Webb Space Telescope spotted a super bizarre space object flying through our galaxy. First of all, it's not orbiting any star. It's a rogue object, just drifting through space on its own. Even better, this wandering thing apparently has a cake-like atmosphere, and examining it can be crucial in our future exoplanet research. Plus, it can help us understand how gas giants evolve over time, and what might happen to Jupiter in the future. You may object that Earth has a layered atmosphere too, with 5 major and several secondary layers. But on Earth, the air is mostly nitrogen and oxygen. As for other planets, they're different. Take Venus, for example, where the atmosphere is super thick and filled with sulfuric acid. There are exoplanets with water vapor clouds, or ones where the clouds are literally made of hot sand. But what about our rogue object? By the way, I have no clue why it got this reputation, but for some reason, scientists chose to call it SIMP. Ouch. Anyway, it seems to have its own unique combo, with cloud patches and weird chemical reactions happening high up. It is covered in clouds made of iron and magnesium, and its atmosphere has carbon-based chemicals floating around. Scientists have spotted auroras on it. Yep, like the northern lights we have on Earth, but way out in deep space. It's the very first time researchers have been able to do a sort of weather report on a rogue object like this. The next weirdness? The object doesn't really fit into any box. It's not a regular planet, because it doesn't orbit a star. But it's also smaller than a brown dwarf, which is something like a failed star. So it's something in between. Not quite a planet, not quite a star. And while it's not dangerous in the we're all doomed kind of way, scientists say rogue objects like this could actually mess things up pretty seriously if they wandered too close to a solar system. Their gravity might throw off the orbits of planets, which could lead to instability, or even space collisions. So yeah, while our rogue friend is not a threat right now, it might become one in the future. Now, this rogue object has some crazy stuff going on. First off, its day is only 2.4 hours long. Like, imagine the sun rising and setting in that time. That's real fast. It's also hanging out about 20 light-years away in the Carina Nebula, which isn't super far in space terms. Another thing that makes this guy special is the fact that it's the brightest free-floating object of its kind that we can see from the northern hemisphere. And since it's just drifting in space without a nearby star messing with our view, it's been directly photographed by telescopes, like NASA's Spitzer. That's actually super rare for stuff this faint and far. When scientists checked it out in infrared, aka heat vision, they noticed that the atmosphere of this rogue object was acting weird, like it kept changing, sometimes more heat, sometimes less. Something funky was going on, but what exactly? So, in July 2023, one team of scientists used the James Webb Space Telescope to dig deeper. They pointed it at SIMP and gathered a ton of data, around 6,000 measurements in just a few hours. First, they looked at shortwave radiation, which is kind of like high-energy heat, and then they did the same with longer waves a few hours later. They discovered that the brightness changed differently depending on the wavelength. Some parts of the atmosphere got brighter, some dimmer, and some didn't change at all. It was all over the place, but they noticed a pattern. All the changes fell into 3 groups. Each group had its own vibe, like its own little signature of what was going on in the atmosphere. And it turned out that the mysterious object wasn't just floating alone in space. It was super dynamic, with layers of clouds and gases doing their own thing. It could mean 3 different things were going on in the atmosphere. To figure out what exactly was behind all this, they built models of the rogue object's atmosphere. Apparently, the first group of curves likely came from low clouds made of iron. Yeah, iron, like actual metal clouds. The second group seemed to come from higher clouds made of this mineral called forsterite, which is basically a magnesium-rich crystal. And it looks like these cloud layers aren't smooth, they're patchy. That patchiness could explain why the light coming from them keeps changing so much. As for the third group of light patterns, they weren't coming from clouds at all. The light seemed to be coming from way above the clouds, from what they think are hotspots in the atmosphere. These hotspots are probably connected to radio auroras, kind of like Earth's northern lights, but happening in the radio part of the light spectrum instead of visible light. But even after all that modeling, there were still some mysteries left. Like the first group of curves was all over the place, more than they expected. So they think it might be because of carbon-based gases like carbon monoxide floating around. They might absorb certain types of light at random times. In any case, this is the first time we've actually seen this kind of atmospheric chaos directly. But the few hours the researchers spent watching it weren't enough to fully figure it out. To really get the full picture, they'll need days of data, and they're hoping to use NASA's Nancy Grace Roman Space Telescope, set to launch in 2027, to dive even deeper. Even though this mysterious object is not a rogue planet, they're definitely worth mentioning. These are basically planets that got kicked out of their home solar system. Yeah, like straight up evicted. When a planet forms, it's usually hanging out with a bunch of other planets around a star. But early on, things can get super chaotic. You know, planets crashing, shifting, getting too close to each other. And sometimes, one gets yeeted right out of the system. So, since they're not tied to a star, these rogue planets are just cruising through the galaxy, totally solo. If they happen to float near something massive, like a star or a black hole, that thing's gravity can tug at them. But otherwise, they just keep drifting. Most of them probably got booted when their system was still forming, and everything was a mess. But according to a NASA scientist, even mature systems can throw a planet out if the orbit gets too weird or something big knocks into them. Now, the next planet we gotta discuss isn't rogue. It has a parent star and all. But there's another cool thing about it. It's still a baby in the middle of forming, and it's pretty rare to catch in action. The baby is already about 3 times the size of Jupiter, the largest planet in the solar system. It's part of a system about 400 light-years away. It's been growing for about 5 million years, munching on gas and dust from the disk around its star, kinda like a cosmic buffet. But the thing is, When astronomers checked out the chemicals in the planet's atmosphere using a big telescope in Hawaii, things didn't add up. They were specifically looking at carbon monoxide and water, which can help figure out how much carbon and oxygen is floating around in that atmosphere. Turns out, the planet's chemical mix doesn't quite match the stuff in the disk it's forming from. That's a big deal because it goes against what scientists thought they knew about how planets are supposed to form. Basically, it's saying, hey, your fancy models might be a bit too simple. Planets are supposed to form by clumps of gas and dust crashing into each other and sticking together. Over time, they build up into full-blown planets. If that's true, then planets and their surrounding gas should have the same kind of stuff in them, chemically speaking. But PDS-70b is doing its own thing. So the scientists came up with two ideas to explain what was going on. It might be forming from solid stuff, like dust and ice, not just the gas in the disk. That solid material has carbon and oxygen trapped inside. So, by the time it melts and goes into the planet, it's already changed the chemistry. Or the gas in the disk got more carbon after the planet already formed. Luckily, there's another planet in the same system, PDS-70c. And scientists are hoping that by checking it out too, they'll be able to figure out the truth.
Okay, it seems scientists have come across a strange object in space, and they're not sure if it's a star or a planet. What we do know is that it's located 1,400 light-years away from us, and it makes us question what we thought we knew about the universe. Let me explain the dilemma here. We can tell if something is a star or a planet by considering the object's mass or the amount of stuff it has. Stars have a lot of mass, which gives them strong gravity that squeezes them tightly. Squeezing creates high temperatures inside them, causing them to shine brightly. Planets have less mass, so their gravity is weaker. They don't experience the same squeezing or high temperatures as stars. Instead, planets shine because they reflect the light from their stars, like our beautiful Earth does with our Sun, too. And this weirdo falls somewhere in between, since we consider it a brown dwarf. It's a special type of big, gaseous protostars. Brown dwarfs are usually like Jupiter in terms of their atmosphere, but they are much larger in size, about 13 to 80 times. If a brown dwarf has more than 80 times the mass of Jupiter, it can start burning regular hydrogen, just like a star. That's what usually makes stars shine brightly. But normally, brown dwarfs are not as hot as stars. Their inability to burn hydrogen has even earned them the nickname of failed stars. They burn at around 4,000 degrees Fahrenheit, which is cooler than most stars. But this object defies the norm. Its temperature measures an incredible 13,900 degrees Fahrenheit. Now let's put that into perspective. The hottest day in history was reported to happen in Death Valley, California, more than 100 years ago, with a temperature of 134 degrees Fahrenheit. People back then must have felt like they were melting along with everything around them. Now imagine getting closer to the Sun, like taking a trip to Venus. Venus can reach insane temperatures of 860 degrees. It's not only about the distance, though. Mercury is the planet closest to the Sun, but it's still colder than Venus. Venus is extremely hot due to the greenhouse effect. Did you know that Venus could have been a delightful place to live a long time ago? Or at least be home to any form of life. But at some point, it started to trap carbon dioxide and eventually created this thick, smoggy oven that doesn't release heat. And that's why it's so hard to explore. The longest a probe managed to last on Venus was 2 hours. But hey, that's longer than I can do at work, and then I melt. So yeah, then you get to the Sun. Its surface burns at an incredible 9,930 degrees Fahrenheit. And what's fascinating is that this weird brown star we're talking about is hotter than that. I mean, it's not hotter than the Sun's core, whose temperatures go up to 27 million degrees, but it's still very impressive and unusual for a brown dwarf to be this hot. At least that's what everyone thought until they realized why it was happening. The brown dwarf is remarkably close to another star that falls into the category of white dwarfs. They're so close to each other that our mysterious star makes one orbit around its white dwarf friend in just 2.3 hours. Whew, how old we'd be over there! Since they're this close, they're tidally locked like our moon and Earth. That means one side of this brown dwarf always faces the white dwarf, and the other side is forever in darkness. Because of all this, our brown dwarf is superheated on one side only. So its day side is what got us confused. While the temperature on the night side is what you would expect from a brown dwarf. But these extreme conditions won't last long. Such a hot temperature makes the molecules in the dwarf's atmosphere break apart into individual atoms. And while its molecules are falling apart, this brown dwarf is slowly disappearing. And if you think this brown dwarf is hot, what would you say about Eta Carinae? It's a star located about 7,500 light-years away from Earth, and it belongs to an elite group of stars we call luminous blue variables. One astronomer first noticed it in the 17th century, but back then, it was just a regular medium-bright star. Almost 200 years later, another astronomer was observing it. But this time, it was a very bright star, one of the brightest ones in the sky. A few years later, it reached the highest level of brightness in a big event called the Great Eruption. When it happened, the star could be easily seen in the night sky. It released so much light, as much as is emitted in a supernova explosion. It remained like that for a couple of years, which is not what usually happens with exploding stars. After the party reached its peak, the star decided it was time to leave. It's still hesitating though, so it's still alive but dimmer than before. There's a nebula around Eta Carinae too. It is a shell made of gas and dust that formed during the Great Eruption. It even blocks some of the star's light. Eta Carinae is a binary star system. That means there are two stars that orbit around each other. One component has a temperature of about 26,500 degrees, and the other 62,500 degrees. The main star in the Eta Carinae system, which is the more massive of the two, is 100 times heavier than our Sun. Because of its enormous mass, scientists predict that this star may eventually explode in a powerful event known as a supernova. But not for another several thousand years. So, by now, you might have already guessed what the hottest thing in the universe is. Ta-da! A supernova. The supernova is what tells us that the life of a star has ended. We're talking about the most powerful explosions in space. They happen when a star that's between 8 and 40 times more massive than our Sun flops. Its core can no longer create enough energy through a process called fusion, so the star can't even handle its own gravity. It's like a stellar burnout, too much work a star can't handle, and its core just collapses. During a supernova, the temperatures in the star's core can get 6,000 times higher than in the core of the Sun. Or sometimes, a specific type of star called a white dwarf suddenly restarts its nuclear fusion, and bam, you get a supernova again. Kepler's supernova happened at the beginning of the 17th century, and it was the last really big supernova event we directly observed from Earth. On average, supernovas in our galaxy happen 3 times every century. I mean, we got a smaller supernova in 1987 too, when a blue supergiant exploded in one of the Milky Way's satellite galaxies, which we know as the Large Magellanic Cloud. This explosion was so strong, people could even observe it with the unaided eye, even though it was incredibly far, 168,000 light-years away from our home planet. What a topic for summer days, huh? But check this out. We can also talk about the hottest thing people have ever created, made in a surprising place, Switzerland. Nah, we're not talking about a super hot chocolate. A group of scientists there created a subatomic soup called a quark gluon plasma. In this experiment, the temperature got 250,000 times as hot as the Sun's core. The purpose of this experiment was to recreate the conditions that existed shortly after the Big Bang, when the universe was still in a state of chaos. Okay, let's get even more extreme. In theory, things can get even hotter. Have you heard of the Planck temperature? It's an insanely hot temperature with numbers so high we can't even imagine. A supernova is like tepid tea compared to this madness. And who even knows what the matter does at these temperatures? Okay, I'm done. Now we take you back to your regular universe. Bye now.
Alright, dear viewer, let's lay it out on the table. The case is cold, just like the rock we're looking for. It's that hypothetical planet again, a real slippery character, warping orbits from the shadows. I've been following its gravitational rap sheet for years. It has left a trail of math miscalculations and confused astronomers. But it can't hide forever. This solar system ain't that big. If it's there, we will find Planet Y. Yep, another day, another quest to solve the solar system's riddles. New research points to another hidden world. I have to say, we shouldn't dismiss these theories until they're disproven. Scientists these days are overloaded with a vast amount of data. Thankfully, they have supercomputers going through mountains of equations bound to give a headache to someone like me. But it's how these theories come to exist. At one point, even Neptune seemed like a far-fetched theory. When Uranus was discovered in 1781 by William Herschel, for decades, it looked like the solar system's final stop. But Uranus didn't quite follow the rules. Something was off. Either the laws were wrong or there was an invisible hand out there. Two math nerds, Adams in England and Leverrier in France, picked up the abacus, and there it was. Neptune appeared exactly where predicted. That's a cool point for math. That triumph inspired the next hunt. In the early 1900s, Percival Lowell became hooked on the Planet X theory. He was sure Uranus and Neptune were still wobbling funny, so he pictured a giant mystery world yanking their strings. His team hunted for years. And in 1930, Clyde Tombaugh found Pluto. Pluto is Planet X? Nope, not so fast. Pluto was too small, it didn't fit. The hype faded, and decades later, Voyager 2 showed that weird orbits made sense all along. Planet X, at least Lowell's version, had never existed. Then came Planet 9. In 2016, researchers noticed that distant Kuiper Belt objects weren't scattered randomly. Their orbits clustered strangely, as if something was tugging them into line. They proposed a super-Earth, 5 to 10 times Earth's mass, orbiting hundreds of AU away. Simulations made it look convincing, but no one has seen it yet. A later discovery, a dwarf planet called 2017 OF201, made things even weirder. Some say it weakens the case for Planet 9. Others say it's more evidence. For now, Planet 9 is still a maybe. However, latest research points to another possible candidate, for now called Planet Y. Unlike the others, it's thought to be smaller, closer in size to Earth or Mercury, and hiding just past the Kuiper Belt. Here's the big clue. Way past Neptune, some icy objects are all tilted, like a bunch of marbles moving to the same side while on a flat surface. That shouldn't happen. Gravity should have straightened them out ages ago. The simplest explanation? A hidden planet, quietly warping the outer solar system like a mischievous babysitter. Astronomers check those Kuiper Belt orbits against the solar system's invariable plane, basically the balance point of all the planets combined. If things were normal, the orbits should line up, but they don't. They're all slanted the same way, like a bunch of pencils dropped on the floor, and somehow every single one points toward the same corner. According to researchers, the odds of that happening by chance are only 2 to 4%. That's similar to flipping a coin 5 times in a row and it landing on the same side each time. Astrophysicists ran their fancy calculations and came up with the simplest explanation. You guessed it, another object with strong gravity. The math shows that a world somewhere between the size of Mercury and Earth, orbiting 100 to 200 AU from the Sun, could maintain that tilt. Not too big, not too small, not too far, just the right size and distance to warp the Kuiper Belt without throwing everything else into chaos. And here's where it gets fun. In theory, Planet Y could coexist with Planet 9. Planet 9 is supposed to pull icy orbits into clusters, kind of like a sheepdog rounding up sheep. Planet Y doesn't cluster anything. It tilts the whole playing field instead, which means if both turn out to be real, we might have two hidden planets shaping the edges of our solar system in different ways. So why haven't we seen this mysterious neighbor yet? Simple, it's faint. At 100 to 200 AU, sunlight is thousands of times weaker than here on Earth. A planet that far away could only reflect a tiny trickle of light. To our telescopes, it would look like a barely visible speck drifting across a crowded star field. Kind of like trying to spot a sleeping gray cat in a dark cellar with only faint moonlight coming through the window. It doesn't help that Planet Y would move at a snail's pace across the sky. Snap a photo one year and another a few months later, and it might not even look like it moved. Older sky surveys weren't designed to catch something that faint and slow. They're great for spotting fast-moving asteroids near Earth, but hopeless for a dim tortoise crawling at the edge of the solar system. But the hunt isn't over. Astronomers are putting their hopes on the Vera Rubin Observatory. This massive new telescope will take pictures of the night sky in unprecedented detail. If Planet Y is out there, Rubin could be the one to find it. And if it isn't, well, Rubin will give us the best proof yet that it doesn't exist. Who knows, maybe it spots something entirely different. But what if Planet Y is real? Where did it come from? Perhaps it's a leftover chunk from the solar system's wild early years. Billions of years ago, when Jupiter, Saturn, Uranus, and Neptune were still migrating, massive chunks of rock and ice were flung around like cosmic bumper cars. Some merged to become the planets we know today. Others were kicked out entirely, ejected into interstellar space. Planet Y might be one of the lucky survivors, massive enough to hang on in a stable orbit at the fringes. Another possibility is way cooler. Maybe it's a rogue planet. Planet Y might just be the cosmic equivalent of an adopted kid or a wandering stray that found a home. So what would it mean if Planet Y was real? First, it would mean a lot of textbooks getting another edition. New picture books as well. It would also challenge how we think planets form. A Mercury to Earth mass that far doesn't fit the standard model of planets forming near the Sun and staying put. Either the early solar system was wild enough to fling it outward and still keep it bound, or it didn't start here at all and was captured later, stolen from another star. There's another angle. Comets. A planet out there could tug on icy bodies at the edge of the solar system, nudging some inward. Over time, that might even have helped deliver water and building blocks for life to Earth, but that's just speculation at this point. However, the biggest question of all would be, what else is out there? If a planet the size of Earth can still slip under our radar, then smaller worlds, icy dwarfs, and other mysteries could be waiting farther out. The Oort cloud might be home to things we haven't even dreamed of yet. Finding Planet Y wouldn't just add a planet, it would open a new chapter in exploring the solar system. So, here we are at the edge of the map, where the streetlights of our solar system flicker out. It's just another theory on top of a dusty desk. Another clue to chase down a dark universe. Some leads have gone cold and turned out to be ghosts. Others, still out there, waiting to be found. Planet Y? The case is still wide open, but one thing's for sure in our solar system. As long as the orbits keep wobbling and the cosmic rug stays wrinkled, astronomers, they'll keep looking. They'll never stop searching for the last planet hiding in the endless dark. Maybe it's just a matter of time. We will see.
So, planets with two suns, like Tatooine from Star Wars, used to sound like pure fantasy. For decades, scientists believed these systems were too unstable to exist. Two stars tugging at a planet should fling it into space or drop it into one of the suns. Except, it turns out that nature didn't get the memo. Astronomers have found a planet calmly orbiting two stars like it's no big deal. This planet lives closer to its two parent stars than any other directly imaged planet in a binary star system astronomers have ever seen. Now, direct imaging means they saw the planet's light, not just its shadow. The whole system sits about 446 light-years away, so the light we see from it today left before humans ever built modern cities. This space monster is roughly 6 times the mass of Jupiter. And even more surprising, the planet is only about 13 million years old. That sounds ancient until you zoom out a little. Earth is about 4.6 billion years old, which makes this planet basically a newborn in cosmic terms. The two suns of this monster orbit each other incredibly fast and complete a full loop in just 18 Earth days. That means their gravity constantly shifts, yanking space around them like a cosmic washing machine. Even so, the planet stays locked in its path, so it takes it 300 Earth years to finish a single orbit. So nobody fully understands how this planet formed in the first place. When two stars orbit each other this closely, their gravity usually tears apart planet-forming material before anything big can take shape. Scientists have only found a few dozen planets like this so far, and that's nowhere near enough to piece together the full story. To solve the mystery, they need more data. Now, another cool find that still needs more research is a planet so stretched by gravity that it looks like a lemon, not a sphere. This planet is nothing like the calm blue and green worlds we see in space movies. It orbits a pulsar, which is basically a star's corpse. When a massive star expires, it collapses into an ultra-dense object that spins insanely fast and blasts radiation like a cosmic lighthouse. Being near one of those means game over for anything solid. And yet, this planet hangs on, barely. The gravity stretches it, pulling harder on the side facing the pulsar than the far side, like cosmic taffy. And here's where it gets extra unsettling. When scientists analyzed this planet's atmosphere, they didn't find water or oxygen. They found helium and pure carbon. No clouds, no oceans, no chance of life. According to everything we know about planet formation, this world shouldn't exist at all. So it might not be a planet in the normal sense. It could be the exposed core of a star that got shredded, leaving behind something stuck between planet and stellar corpse. That's a pretty scary trend. The line between planets and stars keeps getting blurry. And speaking of scary, meet this guy. This system lives around two red dwarf stars. These two stars orbit each other at a distance similar to how far Jupiter sits from the Sun. Scientists found two Earth-sized planets and a third possible one squeezed right up next to the stars. One planet completes a full year in just over 2 days. Another takes about 3.5 days. The candidate planet orbits even faster. To put that in perspective, these planets sit less than 2 million miles from their star. The Moon sits about 250,000 miles from Earth. So yeah, these worlds are close. When they combined data from space and ground-based telescopes, astronomers realized they were staring at something totally new: planets that transit or pass in front of both stars. Most planets in double-star systems orbit only one star, and this setup shouldn't last long according to the rules of physics. But these planets exist anyway, calmly breaking the rules. So this guy proves that planet formation works in ways we still don't fully understand, and space clearly enjoys messing with our expectations. Now, let's crank up the horror a notch. Astronomers made the first ever 3D map of a planet outside our solar system. And not just any planet. This one is so hot it literally tears water molecules apart. As the planet moved behind its star, the James Webb watched tiny changes in the star's light at different colors or wavelengths. Some colors get absorbed by water vapor, others don't. By stacking all that info together, scientists figured out temperatures at different heights and locations in the planet's atmosphere. And that's how they learned that parts of its atmosphere heat up to nearly 5,000 degrees Fahrenheit, hotter than molten lava. This superhot planet sits about 400 light-years away and weighs around 10 times as much as Jupiter. It races around its star in just 23 hours. 1 year there is basically a day. And because it's so close, the temperatures get so high. Winds try to move heat around, but they totally fail. WASP-18b's atmosphere barely has any water and instead overflows with carbon monoxide. Astronomers once believed water should be common in giant planet atmospheres. This world proves water is optional, not guaranteed. Now, magma worlds are another perfect proof of that. There's a huge group of planets called sub-Neptunes, planets bigger than Earth but smaller than Neptune. For a while, some scientists hoped these worlds were Haitian planets, covered in deep oceans of water or ice, wrapped in thick atmospheres. One famous example was K2-18. Its atmosphere showed methane and carbon dioxide, but almost no ammonia. But as it turned out, lava dissolves ammonia too, so the missing ammonia doesn't prove water at all. It could just mean the planet has a global ocean of magma instead. The researchers model how these planets heat up, cool down, and evolve over time. They asked a simple question: do these planets ever cool enough to stop being lava worlds? And the answer was almost never. When they tested thousands of known sub-Neptunes, they say almost all of them are likely lava worlds, not water worlds. In simple terms, these planets don't breathe water vapor, they breathe rock vapor. Their atmospheres come from magma boiling, not oceans evaporating. And that changes everything. Many worlds we once labeled maybe habitable turn into hellscapes the moment you run the numbers honestly. And that means space isn't hiding Earth clones, but mass-producing furnaces and other sorts of monsters. Take this bad boy, for instance. It sits only about 64 light-years away, which is uncomfortably close in cosmic terms, and it's the nearest hot Jupiter to Earth. From afar, it looks stunning, a smooth, deep blue marble floating peacefully in space. But that color hides something absolutely brutal. On this planet, it rains glass, sideways. Winds scream across the atmosphere at around 5,400 miles per hour, fast enough to shred anything instantly. The blue color comes from tiny particles of silicate, the stuff glass is made of, floating in the air. The planet's surface temperature hits about 2,400 degrees Fahrenheit, hot enough to melt rock. That heat turns those silicates into microscopic shards of glass that whip around the planet like a worldwide sandblaster. Standing there wouldn't hurt. You wouldn't exist long enough to ever feel it. And then there's the darkest planet ever found. It reflects less than 1% of the light that hits it. It's darker than coal, darker than black paint. Light just disappears into it. Not all planets even bother with stars at all. Astronomers have found rogue planets, worlds kicked out of their solar systems. These lonely planets drift through space in total darkness, frozen and untethered, with no sunrise ever again. Now, all of this shows us that our universe isn't designed for life. Life survives despite the universe, not because of it. Earth isn't typical, it's lucky. We're only at the beginning of this discovery era. Every year, new telescopes sharpen the picture, and every year, the picture gets stranger. The more clearly we see the universe, the less it resembles our imagination. And that's the most unsettling truth of all.
Check out that buff dude over there with the orange skin. He's been chilling on Mars for a hot minute, which is why he looks like he used the wrong shade of self-tan. You see, all those carotenoids in carrots, sweet potatoes, bell peppers, tomatoes, and pumpkins are protecting him from those UV rays. The more he eats, the more orange he gets. And as for his sturdiness, it's all about that Martian gravity. The gravity here makes us perceive our weight differently. And if you want to be a boss on Mars, you gotta eat heavily. Like, if a person weighs 150 pounds on Earth, it feels like no more than 55 pounds on Mars. So, overeating can help shorten that gravity-to-weight gap. Mercury is a whole different thing. It's hotter than Georgia asphalt during the day, but colder than Elsa's castle at night. You gotta be made of metal, with a high melting point to be able to survive here. But for us regular humans, we'd be toast. Literally. Even though Mercury's the closest planet to the Sun, Venus is still the hottest one. Life on Venus more like life on the sun's evil twin. The temperature here typically hovers around 870 degrees Fahrenheit on average. Surviving at the boiling point of water, or in the extreme heat of Venus, is a challenge for most earthly species. Only a select few can endure boiling hot temperatures. Others rush to Starbucks to grab an iced latte with the first beams of the spring sun. So no human being can really evolve enough to survive on Venus. The only creatures that could thrive there are probably tardigrades and those weirdos who put hot sauce on everything. You wonder what tardigrades are? Well, those are minuscule and adorable caterpillar-like creatures that possess remarkable durability. They can endure boiling water, the depths of a sea trench, and the frigid, lightless void of space. Recently, tardigrades were included in a scientific study aboard a spacecraft that unfortunately crashed on the moon. Scientists speculate that the tardigrades may have survived the impact. Hey, would you like to turn into this creature and live on Venus? We're done with terrestrial planets. Let's move on to gas giants. Now look at this dude from Saturn. He's got flippers and not arms. He's got small holes with no external ear flaps instead of regular ears. Most of this gas giant is colder than your ex's heart, as the temperature is about -220 F. You can't walk on it, but you can turn into a snowball or an ice crystal if you're feeling frisky. Things are quite similar on Jupiter, so probably turning into a seal and chilling there is not that bad of an idea. At least you can live there rent-free. And don't even get me started on Neptune and Uranus. These guys are ice giants with no solid surface, so those sharp-clawed dudes you see in movies? Yeah, they don't exist. Plus, these two ain't exactly hospitable to life. I'll stick to my sweet potatoes on Mars. Thank you very much.
A new super-Earth has been spotted by astronomers, and it's quite intriguing. This planet, called TOI 715b, is about 1.5 the size of Earth, which is why it's called the super-Earth. It's also relatively close to us in space terms, only 137 light-years away. For comparison, most exoplanets are hundreds of light-years away, and all the interesting stuff, like black holes and nebulas, are usually more than thousands of light-years away from us. So, could it be habitable? The habitable zone is an estimate of where a planet might have the right conditions for liquid water. This is what we call some distance from the star, where the temperatures on the planet should be okay-ish, and water should stay liquid on its surface. It's not super precise, because it depends on a bunch of factors like the type of star, how reflective the planet is, its size, and so on. Also, just being in this zone isn't enough for water to actually be there. The planet also needs the right kind of atmosphere and a few other things. So, we invented a stricter definition in 2014, the conservative habitable zone. It's a more precise term defining the best candidates that have liquid water. Otherwise, we get too many potentially habitable planets that are not actually habitable at all. The CHZ is based on how much energy a planet gets from its star compared to Earth. If a rocky planet gets between 40 to 85%, it's considered to be in the CHZ, no matter how far away it is from its star. These planets have a higher chance of being habitable. And yes, TOI 715b is located there. This super-Earth orbits the M-type star, also called red dwarf. It's a star that's much smaller and cooler than our Sun, about a quarter of the Sun's size and mass. But if the planet is located in the habitable zone, it's actually a better option for life. Red dwarfs live much longer than our Sun, a yellow dwarf. This also means that they have more time to form little creatures on their planets. And this red dwarf really is older than our star. Our Sun is 4.6 billion years old, and this star is 6.6 billion years old, give or take a few hundred million. It doesn't have much magnetic activity, so it's not dangerous. It doesn't flare up like younger red dwarfs. These flares can be super strong and might even hurt planets by taking away their atmospheres. Although some planets around it do have thinner atmospheres, it seems like this red dwarf has already gone all out. These red dwarfs are where we're looking for planets that could support life right now. Our super-Earth is really close to its star, zooming around it in just 19 days. Since the star is small and the planet is so close, the planet passing in front of its star happens a lot and looks really clear. This makes it easy for telescopes like the James Webb to study its atmosphere without needing too much time. Now, speaking of the James Webb Space Telescope, it's bringing us into a new era of understanding distant planets beyond our solar system. Imagine being able to see what gases make up the air on a planet millions of light years away. James Webb will help us to find worlds that could support life. Right now, it's trying to figure out whether TOI 715b has an atmosphere. If it does, its atmosphere might be easier to spot compared to a planet that's drier and denser. And then we might get even more height because it would look like a good place for life. On top of all that, there might be another planet in this system, also in the habitable zone. We're not sure whether it's really there, it's just a candidate with a crazy name. But if it turns out to be real, it would be about the size of Earth. Also, it would be the smallest planet in the habitable zone ever spotted by the TESS telescope. Now, another cool thing about TOI 715b is that it cannot just have water on it, but be an entire water world. An ocean planet is a type of planet that has an ocean covering its surface or has subsurface oceans. They might not have much dry land because the water can cover everything. Sometimes the entire planet can be covered in other liquids, like lava or ammonia. When it comes to planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint there might be liquid water below. And of course, we wonder if these planets can have life, hopefully not in the form of Leviathan-like monsters. Our models show that planets with oceans might be pretty common in our galaxy. This means there could be lots of ocean worlds out there waiting to be discovered. But the most important part about TOI 715b is that it's in the so-called small planet radius gap. If we give the planets a lineup, there will be those that are bigger and smaller than Earth. But there's a sudden gap in planets that are about from 1.5 to 2 times bigger than ours. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets don't form in this size range. They actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit their stars, with stars blowing away some of their mass as they dance around it, as our Sun does with gas from comet tails. This gap holds a lot of mystery, and planets like our new super-Earth are clues that could help us unravel it. We aren't sure whether it exists around red dwarfs. Maybe it's a gap in how dense these planets are rather than in their actual size. So studying our discovered planet is even more interesting. It'll help us learn more about distant stars and their planets. Now, I mentioned TESS a while back. NASA's TESS, Transiting Exoplanet Survey Satellite, has been in space for 6 years now and has been incredibly successful. NASA launched TESS because we already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth. We decided to focus TESS on finding smaller Earth-like planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back, it could mean there is a planet passing in front of it. But stars can dim for other reasons too. For example, flaring up or having dark spots on their surface, which is why we need to be careful with this data. TESS shows us the size and orbit of these planets. Then ground telescopes help determine their mass. With these 3 parameters, we can figure out what the planets are made of and if they're rocky like Earth or gassy like Jupiter. Yeah, you want to avoid Jupiter after taco night. One example of TESS's discoveries was the TOI 700 system. There, it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf, and it's even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are crazy. Another big discovery was made in the AU microscopy system. TESS discovered a planet about 4 times the size of Earth and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, including supernova, hot worlds, and so on. And as it enters its 6th year, we can only expect more exciting findings to come.
We've discovered Kepler-22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler-22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler-22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler-22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler-22, the star of Kepler-22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler-22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler-22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler-22b is that it's about 15% closer to its star than we are to the Sun. If Kepler-22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler-22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler-22b will will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler-22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler-22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler-22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler-22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home, while not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler-22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler-22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler-22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler-22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler-22b. That would be awkward if it turns out to be a gas planet, or something like that.
Shh! The planets and the moons in our solar system are hiding secrets that could change our knowledge of Earth itself. Uranus stores heat we didn't expect. Mercury has been shrinking and cracking for billions of years. Jupiter's moon, Io, emits giant columns of volcanic plumes. These cosmic mysteries hint at forces and processes that could, one day, ripple through the solar system and even affect life here on our own planet. Back in 1986, Voyager 2 flew by Uranus. and confused everybody. The readings showed the planet wasn't giving off any extra heat. This made it look totally different from the other giant planets in the solar system. That was strange because Jupiter, Saturn, and Neptune all release way more heat than they take in from the Sun. Fast forward a few decades, and two independent research teams went back through a mountain of observations. What they found changes the story. Uranus does give off more heat than it receives. About 12.5% more to be exact. The two studies show that Uranus is still slowly releasing leftover heat from its early days. That detail matters greatly because it helps scientists piece together the planet's origins and how it's changed over time. As for Voyager 2's odd readings, they now make more sense too. The flyby happened when the Sun was unusually active, which made Uranus act weird, so those early numbers likely didn't reflect its normal state. Even so, Uranus still stands out. Jupiter pushes out 113% more heat. Saturn gives off 139% more, and Neptune tops them all at 162%. And since Neptune is farther away from the Sun, distance isn't the reason Uranus is cooler. Something unique is happening deep inside. Maybe the planet's structure is different, or maybe its past somehow shaped it in another way. Another weird space body in our solar system is Jupiter's moon Io. Oh, by the way, did you know that Io has a brother moon named EIE? So, through a telescope looking at Jupiter, you can sometimes see them. EIE, Io. Right next to Old MacDonald. Hey, I thought it was funny. Anyway, back in 1979, Voyager 1 zipped past Io and saw something jaw-dropping. Giant volcanic plumes were blasting straight into space. It was the first time humans had ever seen active volcanism beyond Earth. Io looked wild, and ever since then, scientists have been trying to figure out what makes this little moon so ridiculously volcanic. For decades, one leading idea was that Io hid a global magma ocean just under its crust. That would explain why volcanoes are scattered pretty evenly all over the surface, as if they're feeding off the same underground reservoir of molten rock. NASA's Galileo spacecraft even seemed to back this up in the 1990s and early 2000s. Its magnetometer picked up a weird magnetic signal that looked like it came from a huge electrically conductive layer, basically liquid rock. By 2011, the consensus was that Io was sitting on a magma ocean several dozen miles thick. But now that theory has been flipped on its head. NASA's Juno spacecraft has been looping around Jupiter since 2016, and in late 2023 and early 2024, it made a couple of super close flybys of Io. The main goal was to figure out what was going on inside. Juno carries a super precise radio transponder that scientists use like a stethoscope. Io's gravity field tugs on the spacecraft ever so slightly, changing the radio signal. By mapping those tiny shifts, the team can see how mass is distributed inside Io. The verdict is there's no shallow magma ocean sloshing under the crust. Otherwise, Juno would have picked up way more distortion in Io's gravity field as Jupiter's tidal pull flexed the moon. But the data showed nothing of the sort. This leaves planetary scientists with a big puzzle. If there's no magma ocean, what's powering the most volcanically active body in the solar system? Io's volcanism is likely driven by tidal heating, because Io's orbit is a little stretched out by the gravitational tugs of neighboring moons. Jupiter constantly squeezes and releases this little world. The crust can rise and fall by as much as 330 feet, and all that flexing creates frictional heat inside the moon. Tidal heating does make magma, but if it's not pulling into a giant ocean, maybe it's stored in smaller scattered reservoirs within the crust. On Earth, different magma chambers feed different styles of volcanoes, but since Io doesn't have plate tectonics, it probably doesn't have the same variety. The new results don't totally rule out a deep magma ocean buried way below the crust. But if that exists, it would be so dense and iron-rich that it wouldn't rise easily to the surface. At that point, it's hard to tell whether we'd even call it a magma ocean or just a molten core. Now, at the same time, Jupiter's moon Europa, for example, is also tidally heated. But in its case, the heat likely sustains a salty liquid water ocean beneath an icy shell. Saturn's moon Enceladus is another great case. The Cassini spacecraft not only found signs of a hidden ocean, but even flew through plumes of water erupting from its south pole. So why does tidal heating make water oceans on some moons, but not magma oceans on Io? The thing is, magma is lighter than solid rock, so it wants to rise and erupt quickly instead of sticking around in one giant pool. Water, on the other hand, is heavier than ice, so it sinks and collects into a stable ocean beneath the crust. That's why magma oceans are so hard to sustain, while water oceans are relatively easy. In any case, even though tidal heating may not be great at making magma oceans, it's excellent at making water oceans. And since water is the key ingredient for life, moons across the solar system, Europa, Enceladus, and maybe others too, could be hiding habitable environments beneath their icy crusts. Io might be a volcanic inferno, but it's helping scientists figure out where else we might actually find life in our solar system. Now let's move closer to Earth and explore Mercury. Believe it or not, this planet and our favorite pastries have something in common. They both shrink as they cool. Mercury formed about 4.5 billion years ago, and ever since then, it's been slowly losing heat. As the planet cools, its rocky shell contracts, just like a cheesecake or cookie that cracks when it comes out of the oven. Mercury develops fractures in its crust. These show up as thrust faults, giant cracks that push up sections of the planet's surface to make room for its shrinking interior. By looking at how those faults have lifted up Mercury's terrain, scientists can figure out how much the planet has shrunk over time. But earlier estimates were all over the place, ranging anywhere from less than a mile to more than 4 miles of lost radius. That's a pretty big range. So figuring out a more precise number has been a long-standing puzzle. To tackle the problem, researchers tried a new way of measuring Mercury's shrinkage. The old method used the length and height of uplifted landforms, but the results shifted depending on how many faults you counted in the dataset. More faults, one answer. Fewer faults, a different answer. That inconsistency made things messy. The new method avoids that issue. Instead of relying on every single fault, it focuses on the biggest one in the set. It's like finding the biggest crack in a cookie and using it as a baseline to estimate how much the whole thing cooled and contracted. Now, to test this, the researchers ran their method on 3 separate datasets. One had 5,900 faults, another had 650 faults, and the last one had just 100. And no matter which dataset they used, the results stayed consistent. Mercury has likely shrunk by about 1.2 to 2.1 miles due to faulting alone. But the planet didn't just get smaller because of its cracks. Scientists added shrinkage from other cooling processes to their fault-based results and found that the planet has gotten up to 3.5 miles smaller since it first formed. These new numbers don't just show how much Mercury shrank, they also give clues about its thermal history. They tell us how fast it cooled, how its interior changed over time, and how its crust reacted to that cooling. And this method isn't just for Mercury either. Researchers think it could also be used to study tectonics on other planets, like Mars, which has faults on its surface too. So, what is the habitable zone? Well, in my room, it's the small section which isn't buried in food wrappings and video games. But astronomically speaking, it's a region around a star where the temperature of H2O matters. Too hot and the water will evaporate. Too cold and it will freeze. So just like Goldilocks, the habitable zone is just right to allow liquid water to exist. And water is essential for life as we know it. Just ask the 3 bears. The size of this zone depends on the temperature of the star, but the habitable zone isn't necessarily a guaranteed oasis of life. Other factors, such as a planet's atmosphere and magnetic field, also play a crucial role in this. Scientists have discovered more than 5,000 planets outside our solar system, and only 63 of them are potentially habitable for life forms like on Earth. Kind of a cosmic lottery. The good news is, this rule also works for the moons. If moons of planets are within the habitable zone, they may also have conditions suitable for life. That would be a jackpot in our lottery, 2 oases for the price of 1. In our solar system, this zone is within a range of 80 to 111 million miles. Of all the planets, only we were lucky enough to have life. But what if we could make all the planets in our solar system habitable? Well, let's start with Mercury. First off, we'd need to give Mercury a bit of a makeover by thickening its atmosphere and providing it with a magnetic field. So let's shower it with some asteroids that contain water. It's terraforming time, baby! Mercury is the closest planet to the Sun, which means it gets plenty of sunshine. So, not that it needs any help in that department. Actually, Mercury needs to chill out a bit. Right now, it's 800 degrees Fahrenheit. That's too hot, said Papa Bear. That's why we should move it to a more habitable orbit, about twice as far away from the Sun as it is now. Now, thanks to terraforming and pleasant temperatures, we'd finally get some water. And if we want to get really cozy, we could always build habitats underground or on the surface, but then we'd have to shield them from the heat and radiation. Anyway, with a little creativity, we could make it work. I mean, people live in Arizona, right? Yeah, but then we'd need a lot of golf courses. Let's move on to Venus. The famous planet of love, where the temperatures are hot enough to melt lead and the atmospheric pressure can crush you in seconds. Isn't it romantic? Venus is referred to as Earth's sister planet, but as it often happens with siblings, we have almost nothing in common. Well, let's try to solve this problem. If we add some hydrogen on Venus, it could react with the carbon dioxide in the atmosphere to form water and graphite. Water would help us to create some oxygen, but for this plan to work, we'd need to get hydrogen from space like it's a Black Friday sale. After that, we can build our new homes. We'll just have to make sure the buildings are strong enough to withstand the winds and acid rain. Piece of cake, right? Luckily, with the next planet, things are much easier. Mars is often considered the most promising candidate for extraterrestrial life in our solar system. It's a rocky planet with a thin atmosphere, but it has signs of water on its surface. And not only water, but even microbial life. So, the Martians must think of us as extraterrestrials. Anyway, if we're going to terraform Mars, adding oceans is a must. They'd thicken the atmosphere and warm the surface. Time for another asteroid shower. Or we could create some giant mirrors to reflect the sunlight and melt the ice caps. Easy peasy. And as soon as oceans appear on Mars, it'll gradually turn into a lush green planet, very similar to our Earth. After that, we'll just need to build some artificial habitats and make sure they have all the comforts of home. Now, making rocky planets habitable isn't that difficult compared to the gas giants. Jupiter has no solid surface at all, and it's basically impossible to colonize. So let's get creative. We could build floating habitats in the clouds of Jupiter, where temperatures and pressures are more Earth-like. We just need to protect them from little inconveniences, like wind speeds of more than 400 miles per hour and lightning every other minute. But if we manage to build homes in Jupiter's atmosphere, we could have some truly unique views. Just imagine waking up every day and seeing swirling clouds and colorful bands out your window, or taking a stroll through the gas giant's thick atmosphere. Scary and awesome. Just watch your step on that balcony. We could also use some high technologies to make Jupiter's atmosphere breathable, something that would consume its gases and release oxygen. Now, this is pure sci-fi, but wouldn't that be cool? Let's move on to Saturn. It's also a gas giant which has no solid surface for life to exist. But don't lose hope. Just like with Jupiter, we could create some floating habitats in the upper atmosphere of Saturn. Try living on a luxurious cloud, although the rent would be sky high. We could also cover the planet with a giant shield, like a cosmic umbrella. In space, it's raining cosmic rays instead of water. But this barrier could protect us from harmful radiation and solar winds. Thanks to this, the weather on Saturn would become a bit calmer. Also, remember how we were talking about moons? One of Saturn's moons, Titan, has a dense atmosphere and maybe even a subsurface ocean of water. Enceladus also hides an ocean beneath its crust. Both of them might be perfect places for actual colonization. That would be much easier than colonizing Saturn. Uranus is another ice giant made up of dense fluid icy materials, methane, ammonia, and water. Considering the surface temperature of minus 353 degrees Fahrenheit, you could say it's pretty chilly out there. So how do we make this work? Well, we could try to create a greenhouse effect. It's a natural process that helps keep the Earth's temperature stable and pleasant, unless we mess around with it. When sunlight enters the Earth's atmosphere, some of it gets trapped by gases called greenhouse gases. They act like a blanket around the Earth, keeping the planet warm, unless we mess around with it. So, if we want to make this ice giant warmer, we can try to recreate this effect, only better. For example, we could introduce some of these gases into Uranus's atmosphere, or build a network of mirrors to trap the heat from the sun. Although it would require tons of giant mirrors, and just imagine trying to position them all correctly. So, instead of all this headache, we could always set our sights on Uranus's moons. They're believed to have rocky surfaces and maybe even oceans that could support life. Plus, the views are out of this world. Moving on to the final planet, Neptune, the cool, distant cousin of the solar system. It's also an ice giant. Its year lasts 165 Earth years. Now first, let's create an atmosphere. Neptune's atmosphere is mostly made up of hydrogen, helium, and methane. Phew. We need to transport some plants there, or simply lots of oxygen to make this place a bit more breathable. And how do we add water to a gas giant? Maybe by melting ice from the moons, or by transporting large amounts of water from Earth. Just imagine a squadron of spaceships dragging giant containers to Neptune. And then, once the planet has a breathable atmosphere and liquid water, we'd need to build habitats. Probably another sky city, because you can never have enough of those. So let's say we somehow magically made all the planets habitable. Now what? Well, there would be a boost in human exploration and colonization. People would build new homes on different planets. Imagine immigrating from Mercury to Neptune because you prefer chilly temperatures more. With more habitable planets to study and explore, scientists would learn more about our world. We'd have so many breakthroughs. Also, it's time for some interplanetary trade. We could mine tons of resources from planets, asteroids, and moons. A dream come true for Elon Musk. But of course, it's not all fun and games. All of this would most likely lead to conflicts over resources and territory. Imagine trying to keep peace between Jupiterians and Martians. Well, all jokes aside, the possibility of all planets being habitable is mind-boggling. But in reality, terraforming planets like this is impossible, at least for now. But who knows? Many things were considered impossible before, but this didn't stop us. So, let's keep dreaming. Meanwhile, we can clean up the planet we're already on. So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to high-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow-spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist. The Earth. Frozen and alone, exiled into deep space. Jupiter, the only remaining planet orbiting the Sun. No, it's not a premise for a disaster movie. It's one of many real scenarios scientists explored in their latest simulations. This time, the threat isn't the Sun swelling or a giant asteroid knocking planets into it like a cosmic bowling ball. It's something quieter and possibly already on its way. A recent study examined the potential consequences of a passing star coming too close. One such flyby could send planets crashing, flinging them into space, or mess with their orbits just enough to cause climate changes. But what are passing stars, and how likely is that to occur? Passing stars are normal stars, like our Sun, that move around the Milky Way. Since everything in space is always moving, sometimes stars pass near each other. Usually it's not a big deal. But if a star gets really close, its gravity can tug on planets like Neptune. That tiny tug can slowly change how the planets move, like a ripple spreading through the whole system. Scientists study these close encounters because, even though they don't happen often, they can have big effects over millions of years. They help us understand shifts in planetary orbits and how they may have shaped Earth's past. In fact, one theory suggests that a flyby 56 million years ago is what caused great climate change when Earth's temperature rose by up to 14 degrees Fahrenheit in just a few 100,000 years. That huge temperature jump changed life on Earth, leading to the evolution of some species while causing others to disappear. Even though it's impossible to prove whether there was a flyby a long time ago, we do know that events like this could mess with Earth's orbit in the long run. That's in the past, but what about the future? So far, we know that the solar system will have a close encounter with another star called Gliese 710 in about 1.3 million years. Gliese is moving towards us and is projected to pass within 10,000 astronomical units of the Sun. It won't come close enough to throw planets off, but it could still send icy comets from the Oort cloud our way, like a bored kid tossing a snowball without looking. One might hit something, but probably won't. However, in a recent study, scientists wanted to explore a more extreme scenario. What if a star passed even closer, say just 100 astronomical units from the Sun? That's about 100 times the distance from Earth to the Sun. From our point of view, it's almost unimaginably far, but in space, it's practically brushing shoulders. They ran thousands of long-term simulations covering up to 5 billion years of our solar system's future, and it turns out it doesn't take much. Just one close encounter can be enough to disturb the outer planets, like Neptune, and set off a slow-motion chain reaction that ripples inward. Over time, that gentle nudge can throw the whole system into chaos, a true cosmic butterfly effect. The good news is that even in this worst-case scenario, in 95% of simulations, the passage is nothing to worry about, and all the planets remain in place. However, in the remaining 5%, well, it's one disaster after another. The most frequent casualty in these simulations was Mercury. In nearly half of all unstable scenarios, Mercury ends up on a doomed path straight into the Sun. It's the smallest planet and the closest to our star, so it's especially susceptible to gravitational nudges, whether from the gas giants or from a disturbance rippling inward from a stellar flyby. When Mercury spirals into the Sun, you might think it's game over for the rest of the planets, but that's not always the case. Sometimes the system absorbs the loss and restabilizes, like an orchestra that keeps playing even after one violinist falls off the stage. Oops. Funny enough, Mercury already has a chaotic orbit, the most stretched and tilted of all major planets, and some studies already consider its fall into the Sun in the distant future inevitable. Now, Venus has a slightly better chance in these chaotic scenarios. It doesn't get ejected or swallowed by the Sun as often as Mercury, but it's far from being safe. Most of the time, the instability happens after Mercury goes rogue and disrupts Venus's orbit, nudging it into a slow-motion crash course with Earth or Mars. Even without the interference from field stars, long-term simulations show a tiny but real chance that Venus could eventually collide with Earth just from the way Jupiter affects Mercury. A Venus-Earth collision would result in both planets being completely destroyed. Oh well. A similar fate awaits Mars. According to simulations, in about 0.3% of cases, it either gets flung out of the solar system or collides with another planet. Mars is smaller and lighter than Earth, with weaker gravity, which makes it easier to knock it off track. What's interesting is that even in some cases where Mars is lost, Earth often manages to stay in place. Jupiter happens to be the heavyweight champion of the solar system, the proud owner of its own cloudy belts. Thanks to its massive size and strong gravity, it acts like an anchor, keeping everything else in check. There are 392 scenarios out of 12,000 simulations where all but one planet vanished, with Jupiter being the last one standing. Its stabilizing influence helps prevent smaller planets from going off course, and in some cases, it even helps the system recover after a disruption. Saturn, while less massive, seems to be Jupiter's loyal partner. But models show that when Saturn shifts its orbit abruptly, it can send gravitational ripples, known as secular resonances, straight into the inner solar system, nudging the orbits of planets like Earth and Mars. Finally, the most vulnerable ones are Uranus and Neptune. Sitting at the edge of the solar system, they're the easiest to knock loose, and in many simulations, they get ejected entirely. That loss sends gravitational ripples inward, disturbing the rest of the planets over millions of years. Even a tiny shift by 0.1% in Neptune's orbital distance can throw the whole solar system out of sync. The balance of gravitational forces would shift, forcing Jupiter and Saturn to readjust, which would push the disturbance toward the inner planets, destabilizing everything. Which brings us to the big question: what about Earth? While most simulated models leave Earth untouched, about 0.2% of the simulations end with Earth either colliding with another planet, Venus, or being thrown into the Sun. Out of 12,000 simulations, in 23 of those, Earth ends up as the only one still orbiting. But that's only if we don't include the Moon in calculations. With the Moon included, Earth becomes harder to predict. Our satellite could crash into Earth, get ripped away by a passing star, or destabilize our orbit over millions of years. Once again, this is a worst-case scenario, and while the odds are really, really small, it's not impossible. So, with that in mind, let's entertain the idea and see what would happen to Earth if it were to end up exiled from the solar system. Earth would become what scientists call a rogue planet, drifting through interstellar space with no sun to anchor it. The surface would quickly freeze, with temperatures dropping to hundreds of degrees below zero. But surprisingly, life wouldn't vanish completely. Earth's core would stay hot for billions of years, powered by radioactive decay and leftover heat from its formation. That heat could keep underground pockets warm. Scientists believe that this is the case with icy moons like Europa or Enceladus. Life might cling on in different caves or buried oceans. It wouldn't be a thriving world, but it wouldn't be completely empty either, at least for a while. Just cold, quiet, and alone. A ghost of a once lively world. And somewhere out there, maybe another civilization will look up, spot a faint blue dot drifting by, and curiously start running simulations of what might happen if this blue planet were to get really close, say just 100 AU from their sun.